Okay, hello everybody. So we will just have some couple of slides for the Friends and Galaxy and the quite old love story. So we start almost in 2012, and we kind organize because we have plenty of small scale server, and we create this Galaxy working group. So to connect the users, the administrator, and propose some training, and we were organizer of the GCC2017. So we are the kind of problem because we are also this bunch of small scale instances. We have a lot of administrators that complain that it was pain to maintain the Galaxy, but some project needs some visibility. So we try to propose one solution, one instance with one admin group, but there was this blonde guy, you know, okay? So he just arrived with an idea, okay, we were thinking about Galaxy France, and he said, okay, I will go with Galaxy Europe. So we're, okay, we are stuck, but we continue with the idea, and we propose a Galaxy at national scale, because it's French community don't speak so much English, as you know. We have this bunch of HPC resource. We want to take part of the load, and we want some independence, etc., and the aspect of proximity to thread the local data. So, Anthony.
Bonjour. So we now have a usegalaxy.fr. So it's the national instance that was launched in 2019, and we have around 13,000 users at the moment with more than 7 million jobs. So it's a quite big one. And yeah, we have more than 3,000 active users in the last years. So that's it. You see a screenshot of the server, and you see also the team behind it. So the most active people on maintaining the server. So most of them are here, and we have also three that left to other horizons. So since like 2 or 3 years, it's a usegalaxy.star instance, which means we are embracing the most common usegalaxy features like federated authentication, subdomain labs, TIAS, CVMFS, and all these kinds of stuff. And everything is managed using infrastructure as code, which means we have all the playbooks that allow us to maintain the website that are online on gitlab.com at this address. And behind our server, there is IFB, which is the French infrastructure, the national one of bioinformatics. So it's decentralized infrastructure, which means we have people working for IFB in many places in France, including Clermont-Ferrand here. And that's, it provides a resource to support this usegalaxy.fr server, and it's always the entry point to the European level because IFB is the French node of Elixir. That's it. So just IFB in a few words. So we have actions, we have communities. So mainly actions are focused on infrastructure, data management, tools, and things like that. And we have communities based on biological domains like health, agriculture, biodiversity, microbiology. And the important thing is that we see that Galaxy ticks a lot of these boxes because it's kind of a service used by all these actions and communities. So it's really a central point in the ecosystem. And so we talked a bit about the Galaxy working group. So between 2020 and 2024, well, the group was kind of asleep, a bit silent, but there was still a lot of people working on Galaxy during this period on projects at the national scale like Emergen, Abromix, or Atlasy, for example, and also at the European scale. With all these projects, I don't want to describe all of them. But then in 2024, some things happened.
Great. 2024, we restarted the working groups. We started, okay, that will be good to meet more regularly, having 2 hours meetings every 2 months. It's what we have since then, which is a good way to share what is happening at each level. So for each of us, we connect also more with Galaxy users, developers, admins across France. We share knowledge, mostly what we heard during the Elixir meeting, because not everybody could be in every Elixir meetings or every Galaxy community meetings. So then it's a way to share knowledge from So top down and down, top, whatever, up and whatever, you understood my idea. The idea is to also support the French server and fight the misconceptions about Galaxy within the scientific community. We know there is a lot, and at the French levels we had, so we try to really combat that. If you are French, you want to participate, there is a mailing list, the link to the mailing list, you can join it. Please join us. There is, you see, a lot of people around France. And recently we had also newcomers like the DataTerra. DataTerra is in a research infrastructure. Like, you have some people from DataTerra here. Can you raise your hand? So there is people here from DataTerra. So it's a research infrastructure, French infrastructure that is about Earth systems science. For example, with land surface with TI, formatter for solid Earth, atmosphere with IRI, PNDB. If you probably heard already about PNDB with Yvan, that is really here, and that now joined DataTerra. Odatis with oceans. And you see the faces of people here that are also in the room there, so you can find them later. And a newcomers also is BRGM, so it's a okay, I'm lost there. It's part of DataTerra, sorry. And now we used Galaxy as its, how did you put it? Sorry, Mary, you should be in the, sorry? Virtual environment for data analysis. So it's all been used. You see, I'm really not part of that. I let the people make the slide and I feel completely bad I didn't do the good work. So there will be talk and poster, you can find them around there. So the current landscape is in 2026, we have 50 members in the mailing list. We participate in the Galaxy Executive Board. We are part of the Elixir Galaxy community. We are also part of IUC, the Galaxy Training Network. We participate regularly to the Galaxy Training Academy. We are in the community board, etc., etc., etc. So we try to be part of the Galaxy community in its large sense. We also organize training. So we have one trainings that is still open for registration. Please register. That will be in October in Paris. That will be about mastering workflows. So the advanced workflow usage, using API, using a lot of other things. So please register. The weather will be much better. I mean, it's October, no heat wave, hopefully, in Paris in October. Others, we are pretty doomed. I mean, and all the French people, can you stand? At least that are here, please. So you can find all these French people here. Thanks for joining, all of you. And you see, they come, they make it possible. So they are from a lot of cities in France. I try to put the names so at least you can have an idea where they are. Probably not everybody is on the picture there because, yeah, whatever. And thanks and welcome to GCC. Welcome to France, welcome to Clermont-Ferrand, and I hope you will enjoy the conference.
Morning and welcome to GCC. So we have a different session. It was debuted last year. The idea is to do a show and tell and demonstrate how Galaxy can be used to go from raw data to a polished result in front of the audience, doing it live. And so as you all likely know, like this process of getting to that polished result is often a messy process. It involves everything from identifying and fetching the data to finding the right tools and then dealing with their quirks, configurations. And Galaxy has over the years made a lot of big strides in simplifying that process, making it more transparent and reproducible. And today we want to demonstrate some of these capabilities, again, doing it all together and live. And so to kind of help us or guide us through that process, we have Diana here, who recently joined the Galaxy world. And before then, she went through, as part of her PhD, she went through this messy process. And so over the course of the past year, we sort of worked together. Diana worked a lot on her own in Galaxy, and is seeing sort of both sides with fresh eyes. And so, Diana, why don't you introduce yourself a bit and tell us about your project and what brought you into the Galaxy world?
Yes. Hi, everyone. Thanks, Anis. So I am part of the Freiburg Galaxy team. And what brought me to Galaxy was actually transcriptomic analysis with single cell sequencing. Yes. And then I also had imaging data. And because it works so well for single cell, I asked Pavan right there if I could also use Galaxy for image analysis. And he told me at the time, this was like about maybe 3 or 4 years ago, and he said, there's some tools that you can use for image data. And I went home and I said, great, maybe this will work. This will speed up my analysis. But I opened the computer, I started Galaxy, and unfortunately, it was not so easy at the time. So I decided to move back my software. Yeah, it was very messy, yes.
All right, so that was 3-4 years ago, right? And so why don't you tell us a bit more about your project first, and then we'll sort of see what we can do today in the modern Galaxy world.
Yes, so to tell you the story about these images, my project involved, so the main question that I wanted to address was, can I modulate the immune response after a heart attack? And the modulation that I did was with a metabolite called furoxoretinoic acid, which is coming from vitamin A. So the idea is that after the heart suffers an injury, a severe injury like a heart attack, it sends the signal to the bone marrow here, this bone, to say, you need to start sending me some immune cells to help with the healing. So furoxo, what it does is retains dormancy, so maintains these stem cells in a sleeping mode so that there's not so much release of these immune cells, and there's a reduction of inflammation. So inflammation is needed to heal the heart after an infarction, but it's too much of it, it's not good. So with furoxo, I was able to dampen this response, yes. And the way I did it, the way I generated these images was I infarcted these mice 2 days after infarction. I treated them for 2 days with furoxo, and then I waited a month until they developed heart failure, and then I cut the heart and generated the slides, and then I took pictures of them with a microscope. And I performed immunohistochemistry to detect these cells that are CD11B positive, which will tell me, oh, these immune cells are there. So the idea is that if the treatment work, I will see less of this immune cells, so less of these brown dots in the images compared to the treatment group. So for that, I needed computer tools. Yeah.
All right. So I guess we're trying to get from sort of in either one of these images, trying to figure out what's the coverage of the brown area in relation to the rest of the image, as we quantify it. So how many of these images did you have as part of your work earlier?
They were, I don't know, hundreds of images, yes.
So let's try this now then, and work through. So we'll go through and download some images and run through it. So we'll use the Galaxy server. And remind me, where do you have your data?
So your private Zenodo into Galaxy. So.
Right. Yeah. So we also have this new upload form, thanks to the Freiburg team to a large degree. Where uploading data from a variety of sources now works, and you said you have it in Zenodo, which is one of these remote files. So again, we can browse public ones and find the Zenodo, which is here conveniently located at the top. So now, so this isn't, we're not browsing all of Zenodo, right? If you just access the standard sort of remote file system, you'll see all of Zenodo. In this case, we're only looking at at your Zenodo file. So
Yes,
which one of these should we?
it's 28 days.
This one. All right, so we have a couple of pages of images. Is that simple? Okay, so we select this, add into the import queue. What are these image types?
TIFF.
Set that. And I guess we want to put these into a collection. So
Yes, you can right away just create a collection from there.
So, all right, so we browse your Zenodo, fetch the private images, and pulling them into Galaxy. Well, I guess this it's going to take a moment just because the images are sort of substantial in size. So I'll do a quick switcheroo for the progress of time, where we downloaded these earlier today. And one thing that I want to point out, I guess, is the now, once these images get loaded, they're visible in, there's a built-in TIFF viewer in Galaxy now that allows you to, before, like, tell it, how'd you do this as part of your PhD before?
I think in Galaxy it was only possible to visualize the image if you downloaded it, but thanks to David here, we're able to have this amazing TIFF viewer.
It's you guys get off the internet. Need more bandwidth. All right, well, trust us, it does work.
Bedroom, yeah. When attending to a phone, that might be easier.
Yeah.
Well, all right, so imagine you saw the image that we saw earlier. So, I mean, you see here, right, we have a bunch of these in a given collection. And so now, of course, the goal is to quantify those brown colored areas in the image. We'll try a different one. So the goal is to quantify that the staining area within the image across all these images. And so, of course, the goal is not to do this one image at a time or one click at a time. So, Danon, why don't you kind of take over and talk to Diana about how we can do this more efficiently today?
Yeah, so, sorry. Okay, so how would you, so we talked about, we got all these images in here. Now, what would you usually do if you're trying to figure out how to do something new in Galaxy?
So in the past, I would just go to Google and type if there's a tutorial, and
Google or ChatGPT or something like that, right? You just now, so one thing we've added recently to Galaxy is Galaxy AI, which is right here. So it's a new feature in Galaxy that allows you to just sort of chat with large language models that have a whole bunch of extra, Galaxy specific functionality strapped to them, basically. So I guess if you're starting here, you could also just ask, hey, what can you do for me? Let's see if Whisperflow works. Hey, what could you do for me? If that works. Okay, so that's going to make the typing a lot easier. So it'll tell you exactly what it can do. This is like a live view of it introspects and looks at all of the available agents, and we'll talk a whole lot about agents later today. But this is an evolving live view of its actual capability. So it'll tell you what it can do and what it can't do, right? So it's not just hallucinating this stuff. So all right, you said I
see some very Galaxy specific stuff in here.
Yeah, exactly. So all of this it's not just, making a request to ChatGPT or something like that and, coming up with what's pre-trained on the model. It's a whole system of agents and tools that provide Galaxy-specific functionality tied to your Galaxy and the greater Galaxy ecosystem. So we were just talking about looking for a tutorial or something like that. You can say,
can you look for a tutorial? Like, can you analyze histology images in Galaxy?
Yeah, let's try. So, can you help me find a tutorial for analyzing histology images? Okay, let's see. So right now it should be pulling up a database of all the GTN tutorials. It searches through them. It finds out, does that look right?
The first one is.
Yeah. So you could, open the tutorial from here. Oh, look at the author. So yeah, it'll sort of it ingests all of the data from the tutorials, and so that's live and regularly rebuilt, so it's always fresh data from the GTN, and it can talk you through the various steps in the tutorial. You can ask questions about it. It uses the actual data to give you answers, right? So it's not hallucinating stuff. So you could start with this tutorial to do your analysis, but what's a faster way might be, a workflow, exactly. So let's say, that looks great, but is there a workflow for analyzing histology images in the IWC? So we're just going to ask it, and same thing, it's going to look at all the IWC workflows and see if there's something that matches what you're interested in. And sure enough, there's a workflow. I'm guessing you might have written this one too. Yeah, okay. So here's a workflow. It'll tell you a little bit about it, how many steps, summarize what you can do with it. Actually, it gave us two workflow recommendations, one of which is the first one, and the other one is relevant as well. So it gives you, if Galaxy AI is confident about the next steps you could likely take, it gives you these sets of sort of quick actions at the bottom that you can just sort of click. So let's give it a shot. Okay. So does that look like your workflow? Look pretty good?
Looks good. Yes, all the steps are there.
Okay. Do you want to change anything, or should we just run it? All right.
So before you run it,
Yes.
we've added over the years. I mean, we've reworked the workflow run form quite a bit. And from here, you can also see a preview of the workflow graph. And if a nice README is included, which you did, you can also open up the README right here. Yeah, so that should help a lot with, like, if somebody hands you over a workflow. And then something in the interest of time, I think we want to enable this functionality here that lets you reuse jobs with the same parameters. Because in the preparation of this, we've of course already run this. But apart from this very narrow scenario, you can use this to continue a workflow if you hit an intermediate error, if you change your workflow, if you've added steps at the end, or if you upgraded a tool in the middle. It will resume from the point that needs to be recomputed because it hasn't been done. So I think. All right, so that looks pretty good. One thing you'll notice is that things are probably not going to turn orange. They go straight from gray to green. That is because of the job cache. So you can pick, like, you can navigate around in this new invocation view. And if you click on something, you can open the job. And then when you see this copied from job API, you know that this has been cached end to end. Yeah, so I mean, this invocation view is a great way to, like, track the progress of your invocation, and we're already done here. And of course, when you ran this the first time, it took what, an hour? Half an hour, okay. Yeah, so yeah, you can navigate through the output files, and this seems to be the primary output generated. So you can reach it either through the step itself, or you can look at it here. Yeah, so does that look about right?
Yeah, it looks right, but I'm wondering, is there something else that I can get from this workflows? Like, is there like a
Yeah.
report kind of thing?
Absolutely. Galaxy might have something that you want to, let's say, give to your PI, right? Like a report of this analysis. Let me show you how that works. So we click on this report tab right here. And I'm not used to the Mac keyboard mouse, but so what you see right here is let me give us more space. This is a runtime report of the analysis. And so this specific report, it also lets you know what this is, but we included a summary of the analysis, and then we have some run configurations and the same tip viewer. It's not loading the image, but you can actually look at each of the inputs, and then you'd know. Yeah, you can explore all of them one by one. This was a collection, right? So you could go in and this works. Yeah, but then there's other parts of the analysis as well that we included in here. And at the very bottom, you have the final output file that we care about. And yeah, this is the final result.
Of course, the one part of this that has never failed until right now fails during everything else went wrong at some point in the past couple of weeks.
A strong machine. You don't need to have like a cluster. You don't need anything, but you do need an internet connection. So we have a reliable source saying that this works better. So fingers crossed. Oh, great. Thank you.
We're not seeing that on the.
Wait, what? Oh, it disconnected Teams, probably.
Oh, we successfully broke it.
Someone needed you to let me back into the meeting. Okay, there's our new slides.
So how does that look to you? For example, we displayed the final output file in here, and it shows you these staining feature results. Does that make sense?
Yes, but is there a way to get like a conclusion from these results? And
yeah, let me actually also show you how this report, where this came from, right? So every workflow in Galaxy comes with something that's called a report template. And based on that template, you can then, when you run the workflow, essentially you can put anything you want in Markdown in the report template, and you can include all of these cool Markdown objects that are specific to Galaxy. So you can include inputs, you can include information about the workflow, jobs and whatnot. And then once you do run the workflow, you then see a rendered report as we saw on the indication view right here. Yeah.
what if I want to add something to the report that is not there?
So while you can create a template right before the run, Now, once you want to, let's say, give this to your PI, right, you can go on and edit this invocation report. So we click edit, it lets us know that, we're going to be creating a new invocation report. And right here, we see that same editor, except did you notice that right here, we actually show the invocation ID and, the actual artifacts that were created from this run. So you can preview this as you like. But the cooler thing here right now in this editor is that we can use Galaxy AI here. So let's give ourselves more space again. And yeah, I think we might need the history initially, but so you click on Galaxy AI, and did you notice it says invocation report right here? So the cool thing is that Galaxy AI now has context of not just what's in here in the report, but it also has context of what was in the history, as in what outputs were created, and then also like the actual workflow. And so let's try this out, right? Let's have Galaxy AI iterate with us and be sort of like our co-author. So let's ask it to sort of give us a conclusion at the very bottom. So
you can type if you want.
So let's ask it to put a conclusion section with a single sentence at the bottom. Summarizing the data. I should have used WhisperFlow. So let's actually, we can, when you type in at, you can actually select histories, data sets, and whatnot. So let's choose that final output file here. And let's see how this goes. So now obviously it's cooking and it's gonna, do what we asked it to do. There you go. So Galaxy AI will then produce things that are called sort of like patches that you can apply. Sometimes it's going to produce multiple of these. So now it's given us a nice conclusion section in Markdown, which we can then apply. And then at the bottom here, probably it's gonna, there we go. It included a conclusion at the very end here. Let's give it some space. And then if we go ahead and preview this, we are going to see that conclusion that we added at the very bottom.
So this is all suggestions from Galaxy AI. I don't need to know Markdown, for example.
Yes, absolutely. I mean, this can just, it just has context of what's in here, but it can also edit, let's say you don't know anything about Markdown. Well, this has you, this can help you out. Technically, I mean, it put the conclusion at the bottom. Let's try this out, right? Let's ask it to move the conclusion at the top. What's the button again? These two? Yeah. Okay. Move the conclusion section to the top of the report. Okay. Does it make more sense for it to be very top, let's say? Working. There we go. It added it to the top and removed it from the bottom. So once we apply, we see it at the top. It's talking back to us. Yeah.
I think maybe one thing to point out is also that we are using open model that is hosted at Use Galaxy EU to do the LLM work. So that's GPT OSS 120B, which is a fairly efficient model that fits in a single GPU. And I think like that's also a very nice thing that you don't have to go use a commercial provider, because you may also not want to open up an expensive key tool however many thousands of users you may have on your server. So yeah, I think something to point out.
Let's say, I mean, maybe you want to actually then eventually share this, right, with your PI. So we can also do that very easily. Like many things in Galaxy, like you can share histories and workflows. Similarly, you can share reports. So you can either, when you click share or publish, you can either make this accessible. And when you do that, you can just share the link with your PI, or you can, or whatever. And then you can also, if you want, publish this to be publicly available in our reports view that we see right here, this activity. So yeah, this way you have like an entire Markdown thing that you can share, view.
And what about if I want to analyze my results from the tabular file, the final one?
Oh, yeah. So if you wanted to do a little bit of extra analysis, so you like we did all this stuff. Yeah. Okay. So after we're done, maybe Marius, you can help us out with this.
So I'll try to. Or collapse it. Right, so that was your final file. And you were saying you wanted to have like a visual summary of this because it's, yeah, I mean, it's 27 samples and they're like interspersed here. And what are we comparing? It's like.
We are comparing control versus treatment, and we want to see if the treatment works. So maybe we can do some statistics.
Yeah.
Not something maybe I can give you the graph, but usually.
Okay. Yes.
Yeah, so I would like to generate a plot that looks like the plots that we are supposed to generate in our group because we have like a typical style of plots.
Okay, so one thing here in the results is that I see there is a sample ID, and I can see that the group is sort of indicated here in the beginning, and yeah, as a sort of prefix. So if we wanted to compare this, I think the first thing we'd want to do is split that up. And that's a nice opportunity to showcase something else we've built recently, and that's the custom tool editor. So I'm going to talk about this later in the session, but just to let you know that you can now create tools yourself. And what we're doing here is maybe just a small demo. You would probably use existing tool to do this particular task of splitting a file on a column. Okay, so there's the editor here, and we can start writing. But this is a relatively simple task, and we can also use Galaxy AI to do this. Let's go full screen here. Start a new chat with. Not tomatoes, prompts. Okay. So I have this data set in my history. And to give it a little bit of context, I am a Mac user, but I just. Yeah.
Not a one-handed Mac.
Exactly. Yeah, thank you. So I'm giving it a little bit of context, and then can we write a custom tool that creates a new group column that is either treatment or vehicle based on the sample ID column? Okay. So again, we're going to use open models in Freiburg to write this custom tool, and this custom tool, I'll talk about it later. It has a lot of context for how a tool should look like. And if you go to use Galaxy EU right now, you are probably not going to see this unless you're the 5 of us. But on usegalaxy.org, we're planning on opening this up pretty soon. Okay, so Galaxy AI was able to do this. It wrote a tool, and just like the interaction with the tutorial and the workflow, you can it proposes this quick action to save the tool in Galaxy. And so then it appears here. It's ready. It could be run. If you know Galaxy tools, XML tools, it look kind of similar, hopefully a little more readable. And this is almost correct. And we fixed it in the dev version, but it hallucinated the container. In fact, the container exists, but I think the version is 2.2.1 and not 2.1.1. But we can still give that a try, and we should see it fail. But for the rest, I think it looked good, and I think this may be a glimpse into the future, and absolutely you could start editing it now. But okay, I mean, we wanted to do the plot, so what other options do we have?
Okay, so this will try to run and will likely fail, you said, right? Okay. So can you tell me a little bit more about wait, it's the one you sent to me, right? Okay. That was terrible acting, right? So you have this particular type of plot you want to recreate. It's a really small image that you clipped out of a PDF or something, right? So we want to regenerate something that's exactly this style. I'm not sure why this isn't running. Oh, it did finish. Okay, so I guess we have to, before we try to plot this, we need to fix this tool, right? So sometimes stuff goes wrong in Galaxy, and at that point, what do you do, right? So one of the really, one of the really interesting things, something that always happens in Galaxy is, when something goes wrong, what do you do? One of the coolest things about sort of agentic harnesses is their ability to retry things and self-heal, right? So something goes wrong, it's going to investigate and figure out, okay, what went wrong? Why did it go wrong? And maybe autonomously try to fix it for you. So I want to show off one more thing that is something we've been working on. This is not open anymore. Oh, yeah, it is. Okay. So this is Orbit. It's a new sort of agentic harness specifically designed for interacting with Galaxy. It's just like an Electron app on top of a pi.dev based agentic harness.
In other words, it's a Mac app.
Yeah, it's an app. You can get it, you can download it, install it, and just run it. And you configure it and set up your Galaxy. We've already set this one up with yours, but just to make sure, like, are you connected to my Galaxy? So just to verify we are actually connected to Galaxy EU. And then what I'll do is ask it, okay, cool, we're still connected. I'm gonna say, in my latest history, Galaxy Live, we were trying to make a user-defined tool and it didn't work. Can you look at that and fix it for me and run it? So hopefully what it's gonna do is connect to that history we were just working on and find the tool that failed. Yeah, okay, so I can look at the Galaxy Live history, identify. So it's asking, yeah, use the same history for the fixed run, just run it again. And it's fine if you make a new UDT. Just make sure that this is the most recent history that we were still working on. All right, so it's clarifying a couple of things first. And then hopefully it connects to, actually, we can show off the activity. We can see what it's doing right now. So basically this thing is just talking to Galaxy, figuring out what's going on.
So you just give it prompts and it fixed the tool for you in your history.
Yeah, you would just talk to it just like, okay, so it found our history, it's gonna look through it, and it's gonna figure out, it's gonna find the failed job run. So it's pulling down context and it's looking through like probably the error messages and things like that. And it should hopefully pretty quickly write a new tool for us that'll work.
Well, it's because Diana, if you got this far and you saw that red box, what would you have done, a month ago or a year ago?
I mean, I wouldn't have done my statistical analysis in Galaxy, to be honest. I would have finished with my tabular file, downloaded it, and work it out outside of Galaxy. Yeah.
Yeah, and we don't want that to happen, right? We want to keep people in Galaxy as much as we possibly can.
And so, but I mean, just to point out, once you break out of that Galaxy shell, right, it will, you lose that reproducibility, right? One of the things that happens here is that once it creates that tool, we ran it with 27 files now, but like you said, you had hundreds of them earlier, right? So that same tool will run on hundreds in the future, and produce that reproducible result.
Yeah, it worked. So all I did was switch over to Galaxy and we looked at the artifacts that it created on this side, and it went ahead and it made a new tool. You can see over here, that's a fixed version, and it looks like it ran it too. So we can go back over here and, okay, so it's going to summarize what it did. That's great. But what we were talking about was, the plot. Exactly. That's what everyone wants, right? Just give me the picture. Okay, so you sent that to me. I'm going to say something like, look at the image Diana sent me in my downloads folder. It's called Diana box plot. And then write a new tool to generate an image that looks just like that using our data in this history. Okay, so what it's going to do is combine with my local, files. It's going to read that. It's going to ask me if it can do that, and then it'll just build another tool and hope it'll look exactly like this plot. Hopefully, is that going to get the job done?
I hope we have to wait.
Okay, so it found the image. It's going to look through it. It is important to note that this is so. One thing we have done here is this is using GPT-5.5. I just signed in with my ChatGPT account. So it's just using my regular $20 a month subscription or whatever. But you could also use open models for this. You could pay for an even more expensive model if you wanted to use Fable or something if it ever comes back. But okay, so it says it's making the plot, making the plotting UDT more robust. And yeah, so I guess it's working on it.
Interesting.
It is, yeah, it's not yet. So one thing I did notice is that this tools panel is not reactive, so someone should file a bug ticket for that. It'd be great if this just popped up when a new tool showed up. Yeah. So it's still working on it, and we are 2 minutes from we out.
Okay.
Okay. The tool, and this should run really quickly now that it's created it. So we'll go back over here. We'll look. Oh, wow, it's already running. Okay. So Diana style IHC plot. All right, let's see what happens. But before that, while that runs, I'm going to refresh real quick so we can look at the tool it made to sort of to see what it actually put together here. I mean, that looks pretty complicated to me. It would have taken me a little while to write this, I think. Look. All right, so we were hoping for something like this, right? And when this finishes, it even put the heart in the top left.
This didn't happen during our test.
But you can see how easily we went from, a sort of a dead end in a broken analysis to just talking to something, and it's able to take over, connect to your Galaxy. And
the cool thing is you can add this to your report. So if you want to send it to your PI, it will include this results.
Can you add this to my report for this thing? Probably should have said notebook. Can you add this to the notebook for the history and document sort of the summary of it?
I was about to say, can you add this to this thing?
Yeah.
Figure that out. I didn't know what he was talking about.
Well, if you didn't know, maybe.
I'm surprised. I remain surprised at how interpretive some of these things have become. But not to keep you away from the break, there we have it. We went from data in that private repository that Diana had to a plot that looks like something she saw in a paper she published a few months ago in 40 minutes in front of a live audience. So I think it demonstrates the capabilities of Galaxy and its extensibility. Again, Diana started on this a year ago and it wasn't this powerful, right? And so while this is imaging, if imaging is not your field, it's okay, nobody's perfect. But joking aside, you see the sort of the power, the capability, the potential that both sort of Galaxy and some of this new emerging technology is posing. And so in the meantime, right, we are all here together for the rest of the week to answer, discuss where should all this go, what's it capable of doing, what it should be doing, what maybe it shouldn't be doing. And with that, we'll see in the break because I think the last step broke.
That was quick. Yeah. Oh, yeah. Yeah. It worked. We skipped the product because of time.
On board to getting a subdomain out. So this will get all these people working in the field, hopefully break down some of the barriers to start with Galaxy in the humanities. And also we have several new tutorials coming up, so keep an eye out. And we have different opportunities to get more into detail. So if you're here in the afternoon, please join us at Poster 28, where we can talk more in detail. Also, we will have a talk today at 4:30. And if you are interested, just scan the QR code and join us in the Matrix channel. You'll get all the latest info. Thank you very much.
Hi, so I'm Mary and I'm here to represent the Earth System Science community. So for those who don't know what is Earth System, it's the interaction between hydrosphere, atmosphere, geosphere, and biosphere. So we are also quite new in the community of Galaxy. So we are trying to build since 3 years ago the community for Earth System Sciences to analyze and process our heterogeneous data. We also have a Matrix channel that was created not long ago. So please, if you're interested in Earth System Sciences, please join. On this Matrix channel, we have different experts like in Earth system, in ecology, but also in climate sciences. And also, if you're interested in any of this, you can join and check out our posters this afternoon. We also have a longer talk during the afternoon where I will present more in detail what we're doing. And yeah, so Earth System Sciences, if you want to join, if you are interested, don't hesitate to reach out. Thank you.
Good morning, everyone. So I'm speaking a little bit about the ecology, things related to Galaxy. I added biodiversity because it's not so easy to make the connection apparently between biodiversity and ecology. It's really interesting because we see that the separation of domains are seen differently, looking at researcher, for example, or IT guys, or from projects or things like that. So I think you know maybe a lot about Galaxy ecology, and I will have a talk about that this afternoon. But briefly, it is dealing with things who are from genetics towards ecosystem, and also societal ecosystem, thing like that. So it's a little bit like the game when you have the train who is like this, and like, whoa, sorry. So we have cross connection with a lot of different communities, with technical communities and or domain communities. For example, of course, with Jess, but also with Daniela on socio-ecosystem things, for example. And looking particularly at genetics, we have also a lot of connections and things like that with biodiversity genomics. I don't know if Solène is there. I don't see Solène, but so if you have questions, comments, things like that around biodiversity, ecology, citizen science, things like that, please don't hesitate. Thank you.
Hi, I'm Paul. I run the micro Galaxy community together with Berenice, but she's very busy with all the things you see here. I think the easiest way to frame it is like there's like a tremendous amount of tools for microbial research, and we try to maintain it and bring them to Galaxy, get new ones to Galaxy, and also deprecate the old ones. And it's just a huge amount of work. As you can see, we have more than 300 tools at the moment, and that tools also include tool suites, which can be on itself like Shime, a few hundred other tools. So we really need input from the community and exchange with the community to see what we should prioritize and put into workflows and also trainings and all this. We like I said, we supported the integration of huge suits, and we're also aiming for new ones soonish. We fight a lot with the challenge of having high compute resource demands, reference data in huge amounts. There's a BOF, I think one of those days for reference data. If you're interested in what we're aiming to do there, you should look at this BOF. And there are also two posters, one for this community, I think today, and also for the Galaxy Codex, which is basically a framework in itself where we try to streamline the organization of our resources. And since we do it for us, we thought it makes sense to provide this for other communities as well. And one major highlight is, like, after 2.5 years of fighting with referees and all this, we managed to get our community paper accepted for communications biology. And that should be out in the next few weeks. The preprint is already there, so you can already have a look at this one. And then, yeah, let's chat over the next days if you do anything related to microbial research. Thanks.
Hello, everyone. My name is Pawan. I'm from Galaxy Single Cell Spatial Omics Community of Practice, aka SPOC. So if you're into single cell, it doesn't matter if you develop tools, tutorials, or if you're a user, SPOC is for you. And in SPOC, we try to prevent work deduplication. We work together to build single cell community and Galaxy and also support the users. Within SPOC, the SPOC has been established in 2022. Since its establishment, when we successfully merged two long-lasting single cell domains on subdomains on EU. And we are one of the first to adapt the Galaxy Labs on concept. And we updated we consolidated all our results into a community paper update in Single Cell Genomics, which was published last year, end of last year. And we also have training resources to cover entire life cycles from planning to analysis to the reuse of the single cell data. And we also have one of the highlights of our single cell tutorials is that we show how you can use Galaxy to work with UI user interface on Galaxy, and as well as how do you do the same analysis on interactive tools like RStudio and also Jupyter Notebooks and so on. SPOC is involved with other communities like Biofair Pathfinder, where it connects Bioconductor, Galaxy, NFCO projects, and where they develop AI-ready interoperable bioconductor single-cell workflows. So if you want to meet the authors of the poster, please go to poster 6 and 15. Now that's session 2, that's tomorrow. And there's also Buff from the Biofair community. It sounds like it's from single cell, but it's actually a general tool maintenance discussion. Please also try to join that. And Galaxy is also part of the Elixir Spatial to Galaxy project, where we implement single spatial workflows, which is in poster session 25. So if you're overwhelmed with all the numbers and of the posters, just go to the poster session 35. And today, one poster to rule them all.
Hello, my name is Lucille. We saw lastly that there were a lot of French people, but I'm not sure that there are a lot of people working in Switzerland. Yeah. So that's why we built the Switzerland community of practice, where we try to make things easier for everyone in Switzerland to contact other people in Switzerland that work with Galaxy. We have different local Galaxy servers that have been set up over the 20 years. And Galaxy, so with Hans Rudolph, we are leading this community and we are organizing some trainings and trying to get more users. Recently, the Swiss universities funded a project called Galaxy CH that aims to bring new tools and new workflows and to set up a national Galaxy instance. So hopefully we will get more users and increase the Switzerland community. So if you're from Switzerland and you want to talk with us, we have a poster number 32 and we would be very happy to increase this community. Thank you.
Last but not the least, of course, it's Marisa and myself introducing the newest. I think we are the newest of the these groups, and it's for the UK community. We recently had our first meeting for the special interest group. It was in May, and we're going to have one next month as well. So we are trying to organize the UK community, which was kind of scattered and not very well organized, like the Switzerland and a few others that are the two type of special interest group. Have you seen? There's a lot of domain-centric, but also country-centric. There's a few of those. So our aim is, as you can guess, trying to get people together, know each other, and help each other as well. We are also aiming to organize training, and Marisa, maybe you, after I finish speaking, you want to talk about your trainings you're organizing. And the other big thing is we are both funded through a fellowship by BioFair, which is a new digital research infrastructure from the UK. And so they're funding us through a fellowship. There's also funding for Pathfinder projects. We have Kevin here from UK, funded by BioFair as well. And the next big thing is going to be probably talk about later in the conference, but is what will become at a certain point the Use Galaxy UK, hopefully. And that will be, obviously, we try to organize the community around it, find what are the needs and what they want from it before we start actually working on it. So that's more or less the plan, and hopefully next year we'll tell you more about it. And yeah.
Okay, so we saw a little bit about, well, I'm Dannon from Hopkins, and I'm going to talk about building an AI native galaxy, what that means to me, talk a little bit about why I'm super excited about it, and then sort of talk about what we've built so far and the things that we're building with the building blocks we have. There are lots of talks in later sessions today and on Wednesday that go into more depth on the things like the notebooks that we saw a brief bit of, the UDTs and things like that. So I'm just going to give sort of a superficial view of the framework. Okay, so what does it mean to have an AI native galaxy? So what we didn't want to have in Galaxy is just sort of like a bolted on subsystem that does very specific things in Galaxy that you have like a little chat box that you slapped on everything. So last year, every application on the planet just slapped the chat box on it, and it's the thing to do. But that's not what we wanted to do. We wanted to have something tightly integrated with the Galaxy framework that exposes the functionality of Galaxy to AI and to users through AI, so that it's just a seamless experience, but it's still fully Galaxy underneath, using all of the same building blocks, right? So sticking with accessibility, reproducibility, transparency for all things. So to give a little anecdote, motivating it, there was a Alpha Genome came out earlier this year, and I thought it was pretty interesting, and I wanted to wrap the tool. This was my first time in many years. I've worked on Galaxy since 2010. It's been a long time. But for better or worse, I don't drive my own analysis at all. I build the framework, but my background's not science, and I don't really do novel things with Galaxy, right? I rerun tutorials and things like that mostly. So approaching a new analysis was brand new to me. But I had this tool, Alpha Genome, that I had wrapped with the help of our Galaxy skills, by the way. There's some really nice skills for writing tools if you need to write a tool. But I wrapped this tool, and I wanted to exercise it before I showed it to other people. So I didn't know what I was doing, but I basically talked to Claude and said, hey, what's a good way to exercise this thing? And I thought this was such a cool learning experience for me to have a tool, get it into Galaxy, figure out a way to exercise it. And it walked me through basically this a real analysis, all driven from Claude Code on the outside. And it just felt like magic, right? I was in my terminal, and then I'd go over to Galaxy and I'd see exactly what we had done together. And I was able to ask questions, and but it just felt so native to, like, it was all still Galaxy, but I was just talking to an agent to do my whole exercise. So underlying it, everything was in Galaxy. It proposed an analysis and ran it, where there were little, gaps in tooling, right? We have a whole bunch of tools in Galaxy, but you always need to like change the shape of a file or whatever. We used UDTs automatically to build the thing, to fill the gaps, all driven from the outside. Importantly, I'm not recommending sort of vibe science here, right? We don't want to just hook everyone up to Galaxy or a bunch of agents up to Galaxy and say like vibe code all the science. But it made Galaxy more accessible to me, I guess, is the reason I'm so excited about it, because I could just interact with Galaxy through the same way I interact with code bases, right? So anyway, that's what motivates me. So how we got here, a year ago, we introduced the Galaxy MCP server. MCP is Model Context Protocol. Basically, it's a set of tools that any agent can hook up to do things in the world and to get information back into the context so that the agent can reason and do the next steps. So we built this agent framework inside Galaxy. The idea we had was to have specialized agents encapsulating specific functionality. So like there's an agent for finding tools and recommending tools. We saw earlier today the agent for recommending tutorials and interacting with data in tutorials. So there's a whole bunch of little pockets, a whole bunch of agents that do specific things. And originally they were just prompts, right? So we have, a history agent, and the prompt was like, you're a brilliant agent that's good at interacting with Galaxy histories. And obviously that doesn't work so well. So you immediately need tools for these agents. So we started adding tools to the Galaxy agents in Galaxy, and then realized while we're rebuilding an MCP server inside Galaxy, it started to look like sort of an internal MCP server. And then there's this sort of like, okay, wait, do we just expose Galaxy internals to the agents? We don't want to do that, because then that creates this sort of privileged access that's less easy to audit, less easy to control. So what we wanted to do was build a formalized MCP server inside Galaxy. So now that's in now, and we call these agent operations. It's sort of one set of tools for all of Galaxy's agents internally to use and externally. So it's the same set of agents you'd hook up, or same set of MCP tools you would connect your Claude code to. And moving forward, all of the stuff that's built into Galaxy, all the Galaxy AI stuff uses this layer. So here's a picture of the layer. So you have sort of our classic Galaxy service layer. It's been around for years, and the REST API that everyone's used to dealing with. The REST API is what Galaxy MCP currently connects to. It uses BioBlend to talk to the API to drive specific operations. And now we have this agent operations manager that both Galaxy internally, the agents, and the MCP server that you can connect to use. So the agent framework has sort of, we built it on Pydantic AI, and each agent is a class with a set of functionality built into it. These are the ones we have right now. So they're specialized functionality agents. There's the error analysis agent. We've seen the custom tool one, the training one, page editing. You can imagine adding more. The main thing you interact with is this routing agent. So basically, when you open Galaxy AI and you ask a question, the first exchange goes, okay, what's the intent here? What's the user trying to do? And if it can figure out what it is, it answers, if it's fairly confident. And if it doesn't know what it is, it knows that it has a set of other agents that it can ask. Like, okay, this person is trying to edit a page. So let me hand this off to the page agent. And it's a good way of encapsulating specific functionality in little buckets, right? There's another sort of meta agent called the orchestrator that is still very much in progress, a work in progress. But basically it allows coordination of agents. So it would allow you to use the history agent, inspect some data sets, and then maybe based on what those say, look for a tool recommendation, right? So you could chain agents together using this thing. Again, very much a work in progress. I don't want to overstate that. So the anatomy of an agent, what's one look like? It's a class. It basically has a prompt, tools, and then importantly, it has structured typed outputs. So what an agent responds with is able to be displayed in a consistent way in the Galaxy UI. And so like the structured output is those little 3 minutes. Oh my God. Okay. I'm going to have to go fast. So we saw a little bit about, I can skip over some of this since we saw quite a bit of it in the live presentation. But you can see Galaxy AI sort of pulls together the agents and the tools or whatever, but it also is context aware and it knows where you are in Galaxy. So it knows the route. So when you're looking at a tool panel, right here, the screenshot's kind of blurry here, but I was looking at the Alpha Genome tool and it puts up a little bar up at the top that says, this is the Alpha Genome tool, and anything you talk to Galaxy AI about is going to inherit a bunch of special context showing in real time, like a bunch of information about that specific tool to be able to answer your questions better. So it also, importantly, Galaxy AI it's not intended to just do stuff on your behalf. It can provide options, but right now we don't have it just do things in Galaxy. We leave that for the external agents to drive. And that's why we open it to outside agents. So outside agents allow you to connect a bunch of different MCP servers together and drive Galaxy. There's sort of if I have a Claude Code setup that's probably different from everyone else's Claude Code setup in the room, right? It's a very everyone has their own set of skills and things that they want to work with. So having the ability to interact with Galaxy from the outside is super important. But we have the same building blocks inside. We saw the self-healing thing. That's one of the superpowers for running Galaxy from the outside, right? You can have long runs. You could set up a workflow, say, okay, babysit this thing. I'm going to go mow the lawn. And it's going to run the jobs. If they fail, it's going to look at why. And it's all driven through Galaxy without you having to watch it, basically, babysit it. It's this, in a Galaxy analysis, when the red box happens, there's a fork, right? Okay, what do I do? And this helps you deal with it, running Galaxy from the outside. So again, we talked about Orbit a little bit. That's the Electron app. Loom is sort of the brain underneath it. It's also a CLI. You can just run, npx Galaxy Project /Loom. It's the same exact pre-configured harness. You can play with that now. I'll skip notebooks completely since John is going to give a great talk on that on Wednesday. But basically, everything that you do with Orbit and Loom is documented in a notebook that interacts with Galaxy's notebooks. And so you keep a record of the steps that happened and the whole analysis. Okay, so I will say it's early and moving fast. We do currently have the internal and external MCP servers. The external one is still very much in use, but it's a good place to prototype functionality if you're interested in developing this stuff. But we imagine those surfaces aligning over time. All right, thank you. I will say I have so a bunch of acknowledgements, but there's a poster if you want to actually come and try Loom. My poster is going to be my laptop. I'll just sign you in and you can play with it and interact with Galaxy and try to do something. I think that'd be a lot of fun. And there is a birds of a feather meeting later today for agentic Galaxy stuff if you'd like to come and talk. And that's it. I don't know if we have time for questions.
Do we have any questions from the room? Someone is waving very far away from me.
What's the logic behind bypassing the Galaxy API? So, yes. So the question was, what's the logic behind bypassing the API? So we want it to be accessible from inside Galaxy, and the API endpoints do a whole lot of stuff that we don't need from inside, but we do use the same exact service layer and managers that populate the API, right? So it is the same, authentication, everything works the exact same. It's just a different, it's a different shape of response, I guess. Yeah.
That's a close person. Do you want a microphone?
I can repeat if you don't want to run around.
Thanks. So this seems really cool. I was wondering, and sorry, this isn't my area of expertise. Have you thought about at all looking at something like RAGs, these sort of in the style of like Notebook LM or something to try and reduce hallucinations?
Yeah, so well, it's not an embedding based RAG, but the GTN materials is effectively a RAG. Basically, we pull down the whole GTN, we pull it into a whole bunch of parts, put it into a database, and we search that using FTS25 to get the live actual materials to respond with. So everything that comes through Galaxy AI that's saying, hey, there's a tutorial that does this, should be coming from the latest and greatest GTN materials, for example. There is work in progress, Noop is here somewhere, right there. I was looking right at you. He's working on an embedding based version of this effectively. Okay.
All right. Thank you very much again to Dannon. And our next speakers are Tyler and Jeremy.
All right, so I'll get going in the interest of time. I'm Tyler. I'm going to be presenting today with Jeremy on some work that Junhao, Paulo, Jeremy, people from his lab have been doing, and then some of the things I've been doing as well on sort of trying to like benchmark these AI agents, try and confirm that they're not hallucinating, that they're working how we want them to, that they operate in Galaxy correctly, and that they give you like meaningful responses. So I will be kind of covering part one here, which is sort of a testing within Galaxy itself. So for some motivation and from some of the questions we heard, there's always some concerns with AI. You want to verify that it's like answering questions correctly. Is it actually assisting scientists? Is it doing it in a predictable manner? Like very often there's like some decently high stakes. If an AI within Galaxy is suggesting tools that don't exist within Galaxy, or it's giving you incorrect code, or giving you a wrong form for like a file that you're trying to send to a tool causing errors, that's like big friction points you really don't want users to hit. Additionally, all these different AI like endpoints and internal agents can use different models. So whenever, I'm sure everyone's seen it, but like monthly, there's new models that come out of Claude, OpenAI, different open source models, new Chinese models. And each of those can introduce new behaviors for how these different routes and are responding to user questions. And additionally, we really want to try and like optimize the responses from the AIs to make sure that they're giving you something plausible, that would be scientifically sound, that you can use, that makes sense to your analysis and works well within Galaxy. And I guess kind of in like the blunt way, how can we make these agents work in a way that actually works and like you're not concerned and you don't question the results, or you wouldn't question someone using an analysis. So to begin with the testing, this is kind of a more simplified version of the router agent architecture. But whenever a user enters a query, it usually goes to the router. The router does some form of like intent interpretation and then passes it on to other subagents underneath it that will run it, run the response. So that can be anything from the tool recognition you've seen to user-defined tools, error analysis, et cetera. However, across all of this, we want to be testing how this is working. So on a base level, we want to be testing like router decisions. How is the router deciding what prompt you give it goes to which of these subagents? And specifically, we also then want to test all the subagents and their MCP functionality. Are the agents hallucinating? Are they giving you factual errors, wrong tool names? Are they giving you like horrifically out-of-date suggestions? If you're giving it long-read data and you're saying, can you help me with quality controls, or running like fast QC and telling it to run it rather than something that would be make more sense. And then additionally, is it like trying to like pass you like weird or incorrect things from the GTN that don't necessarily align correctly, things like that. So to do that internally, I was working with a testing suite called MCP eval. This is a suite that uses OpenTelemetry as its like backbone, but essentially what it does is it goes through and tests all of these subagents, and you can, I'll show you here in a minute, write your tests to track all of the actual parameters coming through. You're able to test, anything from latency to individual MCP tool calls, how things are working there, which AI, if you're doing it from external, you can see which API endpoints it's hitting. You can track all of your fun performances you're looking for. And then finally, you're able to do full structural tests of responses within it. And you're able to use Okay. You're able to use secondary tests where you can basically write a user-defined rubric for a question, and you're able to take the response that would come out of one of the agents and then score that and then see how well it does. So to kind of see what more of this looks like, here's one of the very basic tests. Right now, there's about 55 that are written. You kind of take an input prompt that you would get from a user question. So in this case, if someone just has, adapter contamination, whatever their read file is they're inputting, like, how do you fix it? You just kind of define that as a pydantic test. Within that, you're able to define which routing or which agent it should hit coming out of the router, or any like MCP specific API points it should hit. And then you're able to pass in a rubric that can be used for judging. So in a case, this is all user defined by who's ever writing the tool. So in this case, it would be like kind of, we're hoping that we'll recommend something to like do quality control afterwards, do some kind of trimming to remove low quality bases, etc. All this then gets stored as JSON outputs, keeping track of everything that was run, how it was passed, where it moved, latency, cost, and then all this gets saved and created and pushed into a dashboard for a quick comparison across things. And what this lets us do is we're able to take all that information and basically run these giant test suites of about 55 tests across a bunch of different domains. We're able to swap out the agents, like LLM they're using, so we can test the same agent, like the custom user-defined tool agent, if it's using a Claude model or an OpenAI model or something that's publicly available in TAC in the United States. And you're able to see how it's scoring across all those different questions. And then you can do a comparative benchmark both across time and between the models themselves, just to make sure you're getting like some kind of validity for what's coming out. And with that, I will pass over to Jeremy to talk about benchmarking kind of outside Galaxy through the other agents.
Excellent. So good morning, everyone. My name is Jeremy Gex. I'm one of the PIs of the Galaxy project in the United States. I'm presenting the second half of the talk on behalf of Junhao Chu and Paolo Lyra, who are members of my group at the Moffitt Cancer Center, and they've been working on benchmarking coding agents with Galaxy. So if you look at the performance of AI agents when it comes to doing bioinformatics and biomedical data analysis, it's pretty encouraging in terms of levels of accuracy. So there are two benchmarks that I'll briefly introduce today. One is BixBench Verified 50, which is a scoped down, very focused set of bioinformatics analysis questions that have been developed. There are 50 of them, as you would expect from the name. And then secondly is CompBioBench, a more expansive benchmark that looks at a bunch of different tasks, and I'll get into them in a minute. As you can see, in general, the agents are getting somewhere between 70 to 80% of their answers accurate across these two benchmarks. It's really interesting to note, let's see, you can see my cursor here. So in terms of the CompBioBench, using the large language models without a coding harness leads to much lower levels of accuracy. So what you're seeing here is if you were to enter this text into a web interface versus here you're using the coding agents to develop these solutions. This has been introduced this morning, this notion of being able to identify errors, to potentially solve those errors, and to loop repeatedly until you get an answer are all part of the aspects that lead to this better performance up here. So these benchmarks lead you to the conclusion that these AI agents can solve these tasks in different domains, such as phylogenetics, RNA-seq, functional genomics, image analysis, and so on, and also different style of questions. So CompBioBench looks at things like metadata recovery, routine analysis, even some machine learning analyses. And so the question that we were pursuing, that we are pursuing, are can you use these AI agents together with Galaxy to accurately answer bioinformatics questions? So how do, when an agent performs an analysis in Galaxy, do we get the correct answer? So let's start with BixBench. What we did here is we took Codex GPT 5.5, which is a modern coding agent from OpenAI, and we paired it together with Galaxy. So this is a command line agent. It has access to Galaxy's API. So speaking of APIs, that's what we're using here. A really simple setup. And we went through all 50 questions and scored the agent about whether it was able to use Galaxy to get the correct answer. So let's see. Importantly, the rules of the game, so to speak, in terms of what the agent could and couldn't do, is that it was supposed to resolve the task or complete the bioinformatics analysis only using Galaxy on usegalaxy.org. Only using Galaxy tools. And we actually scoped this to use tools that were not free-form programming. So we tried to avoid tools like Jupyter Notebook, where the agent could script a whole analysis itself. We really wanted this to be an experience where the agent was using established Galaxy tools. In my opinion, one of the values of Galaxy in the age of agents is that these tools encompass best practices and known behaviors that you can take advantage of rather than writing code that you have to check yourself. So being able to trust those building blocks that are out there in the world, in this case, the large suite of Galaxy tools that are out there, is a big advantage. So we wanted agents to take advantage of that. Got it. And so to get to the final results, we were able to demonstrate that Galaxy achieves, or the agent achieved equivalent accuracy using Galaxy versus just writing the code itself. So both achieved 90% accuracy. This is important to us because we can demonstrate that these agents are able to use Galaxy while they perform these analyses. Now, to get to some of the stickier questions here, agents do use different approaches to get to the same answer with Galaxy oftentimes. So here we have 3 different runs of a particular task. Sometimes it uses a different set of tools and different set of order. It's, I think, an interesting question about how we deconvolve this and what we're optimizing for as a community. Are we optimizing for understanding from a user perspective? Are we optimizing for token usage or something else? So what did we learn in Bixbench? Number one is that tokens, Galaxy uses a lot of tokens, or agents use a lot of tokens with Galaxy, which can make things really expensive. They use a lot of tokens because of this constant communication with the API. You can make that more efficient by developing skills. We had to introduce a lot of new tools into Galaxy to get these benchmarks to work. And then secondly, or lastly, the remaining errors that we saw are really around this notion of methodological knowledge, biological knowledge that the agent doesn't necessarily have, as well as some missing tools. We haven't fully completed our analysis with the CompBio bench if we switched to the second benchmark, but what we have done is a feasibility assessment. This is a much more broad-ranging benchmark, and so our first question was, what can we reasonably expect an agent to be able to accomplish with Galaxy? And so far, we think it's about half of the 100 questions that are in CompBio bench that you can actually complete inside Galaxy. Right now, there are others that we're uncertain of, or that new capabilities would be needed inside Galaxy. In our benchmarks, you can get Codex 5.5 using code alone to get about 88% accuracy. And so in summary, what you've seen is that Tyler introduced this really nice framework called MCP Eval that allows you to plug in different agents, different questions into Galaxy and benchmark those along the way. And what I've shown you is that you can use Galaxy together with agents to get relatively accurate answers to bioinformatics benchmarks that are out there in the world. This gives us confidence that agents can use Galaxy effectively to get the right answer. The next steps are to expand Galaxy's MCP Eval test suites for all Galaxy subagents. And then from the perspective of looking at the scientific accuracy of Galaxy, we want to balance cost with performance. And so thinking about how you can start to use open source models, this field is changing really quickly. So whether it's DeepSeek or GLM or another open source model, that would be great to see how that accuracy of those agents compare to Codex. And then can we get AI and Galaxy to perform well in a more complex benchmark? This CompBio bench is an open question as well. So thank you so much.
With MCP Eval, would you be able to benchmark or assess the security aspect of the AI agents?
You're able to track exactly what it's calling and how it moves through the stack. Basically, it's throwing out spans to that open telemetry system. I haven't looked into that quite as in depth. I was mostly looking at like accuracy and ensuring it was moving correctly how it was expected. But in theory, you could also include that, yeah.
Hi, my question was, do you think, you talked about some of these things of like developing skills or things for the future, but I'm wondering if this could even be, you know, useful for understanding where there might be gaps in like the Galaxy documentation more broadly. If you have an agent that's struggling on a couple of things over and over again across different pieces, could this be used to like, you know, maybe to get a higher thing of, yeah, the agents are all having to recreate this time and time again. Could we use this as a way of basically improving the Galaxy documentation itself so that everyone's reading in the future and not having to rework it?
You could. I think you could do that based off the external one, but in the internal one, for example, if you're like testing the GTN tutorial agent specifically, which is pulling its information from the GTN tutorials, and in the test I've written, it covers like it's not comprehensive, but it probably covers, like proteomics, metabolomics. There's some like single cell in there. If you're consistently failing and like pulling out weird parts from that, regardless of which agent you use, and it's coming directly from that, it's probably a good flag that you could use it to try and buff up the tutorial suite. In general, I think Jeremy's approach, if you're like consistently failing on like you're missing certain DE-seq parameters and tools, that's a good flag that you could also update the tools within the IUC or on whatever server.
And our next presenter today will be Ahmed, who is talking to us about Beyond the Tool Panel.
Hello, bonjour à tous. My name is Ahmed Awan, and I am a Galaxy developer, and I've been working at the Michael Schatz Lab at Johns Hopkins University. And for this year's GCC, I will be presenting some of the latest improvements that we've made to the user interface of discovering and managing tools in Galaxy. So as we all know, tools lie at the very core of Galaxy's user interface. A user's very first interaction with Galaxy is probably finding the right tool, and then providing the inputs for it, and then looking at the outputs for it in the history, right? We have a solid infrastructure to support thousands of tools on many servers in Galaxy for that purpose. Therefore, on the Galaxy interface itself, the tool panel on the left is often the first place a user will look. And as we can see here, the panel has evolved a lot over the years. We've seen many new aspects to it, like panel views and whatnot. I mean, the activity bar, it's not the only panel you see there either, right? However, we've discovered that there are potentially two gaps that we can fill with this with the user experience here. As we sometimes hear from our users, unless you already know what tools are available, obviously, that instant client-side search doesn't really work like you would expect, because in the way we improved it in the recent past is that it just returns results right away, and it doesn't show you a sparse list, which is very mixed because that was bad UX in the past. And then I'll go into that. And on top of that, the per Galaxy server defined sections don't really reflect how individual users work, because everyone's doing a different type of analysis. So you want to basically make tools easier to discover, and as well as being easier to access on the interface. So for example, let's say you want to find a tool for sequence analysis. Well, if there's no tool with that exact same name, you're not going to be able to see it there. And then also, like I said, about the predefined tool organization, regular users who want to quickly access their frequently used tool will have to dig through this long list, and it's not ideal. So therefore, to sort of bridge these two gaps of the discoverability and the accessibility of tools, we've created two new features. One is the tool discovery view, and then there is also the personalized panel for your tools in Galaxy. So I'll go into the tool discovery view first. So by clicking on the tool activity in the activity bar, you'll see this Discover Tools button. And this takes you to a rich full-page interface that will list out all the tools that exist on this Galaxy instance. And it's meant to be Galaxy's very own search engine for tools. So we organize tools by a comprehensive ontology that's called EDAM. I've provided a link for that there if you want to learn more about it. But quickly explain what it is. It is essentially familiar concepts between data management, particular to bioinformatics, that are available there. And so by clicking on the ontologies button, it shows you all the ontologies that are available. And then you can narrow down by clicking on there. Let's say you click on an ontology, it'll show you all the tools that are relevant to that specific operation. Otherwise, as we've done in the recent past, we're trying to make our interface more and more uniform, so that more views look similar. So yeah, you see, instead of just seeing the names of the tools as we do in the panel, you see much more about each tool here. But I'd like to note that with Dan's talk, as well as the one before this, we have really nice agentic operations in our backend. And so why not use that here as well, right? So as we heard, there's a tool recommendation agent that's available. And all it takes is a plain English, or whatever language query. And it searches the toolbox to return rank suggestions with reasoning. And it goes beyond keyword matching. It understands, inputs, outputs automatically. So you can just say, find me a tool related to X, and hopefully it'll return a few results for you. And this is accessible via the Galaxy AI chat. So we could easily bring this into this tool discovery view. And like we're seeing recently with many, many search engines, you'll see these AI results at the top that you can, choose to select a tool from there as well. So we hope that this tool discovery view, it is a direction of, filling that discovery gap that we have. But so to make tools easier to access for regular users, we've come up with this thing called a personalized panel. And so this is built around the tools that you will use regularly. So we've had panel views for a while, which when you click on one of those panel views, it'll section tools differently. Well, now there's also a My Tools button. You click there, and it takes you to this new favorites or My Tools panel. And so this has two sections. At the very top, it shows you your recently run tools. So as that makes sense that you run a tool, it'll pop up there. Obviously, there's a max number of tools that will show up there because we don't want to make this sparse as well. And then you can, as we can always, favorite tools will also show up. And the idea is you sort of use motor memory and you remember that, oh, I always know this tool is right there. So you click on it, insert into your workflow and whatnot. You can obviously also drag and reorder these tools to remember where you put them. And this discovery view sort of works in tandem with the personal panel, in the sense that you'll notice that we also see sections in there now. So the idea is that instead of just going by whatever the server admins have provided you in the tool panel, you've become sort of your own admin for displaying those tools. That's cool. So what's next? It's only the beginning in making your user experience for tools more customizable in Galaxy. We're planning to introduce community tool mappings. So we'll have YAML files that will, because with ontologies, we only go by what EDAM has. But if the community themselves mark each tool with different tags, we'll then be able to make our search more powerful, because then each tool will have more metadata to go by. And then we'll also want to make tools taggable, just like histories or workflows or data sets can be tagged, and then that's stored in the database. Tools will also be taggable. And as users, different users will have their own personalized panel. We could also make them shareable, and you could publish them and make them available in tool grids in the interface. So I'd like to thank Bjorn, who was critical in coming up with the idea of the My Tools panel, and David for helping out with that interface as well, and also Danon for all the agentic operation stuff that we've had in the past. And as always, all developers who've worked in the last couple of years, because this is the work that's been done in the last 2 years. So everyone who's worked on improving the front end and the API of tools in Galaxy. And thank you. I have poster number 3 today, if you want to see an overview of the changes.
Thank you for the nice talk, and really thank you for this work, because it seems to me Galaxy platform well a good job, notably last years, to ameliorate a lot of things considering UX or UI and things like that. And for me, it seems really that the last pieces of things we have to work on is this tool panel. So really, I think the direction you are taking, providing the things as functionalities around the tools and tools panel is really something important for the communities, notably. So really, thank you for that. My question is simple. Is the tool panel, as we have seen since years in Galaxy, something will disappear, and maybe in the coming months we will have something like just the use of so the My tool panel by default, something like that? It can be maybe something that will push forward the manner that we want to train also users to first create their own tool panel and using it and updating it, something like that.
That was the entire thought behind this, is that I mean, Bjorn was like, let's just get rid of the tool panel as we have it. Just make like you go to the discovery view, you use these tools, they show up in that one panel when you click on the activity bar. With the activity bar, right, already, I mean, in the past for many, many years, the tool panel was always there with this whole bunch of information, which could be intimidating. So now, I mean, you could, let's say, discover tools, add them there, and then only use the tools that you need. So that is the idea. It currently also persists. So if that's the view you've set and you come back to it, it'll open up the My Tools panel every time. So users who just want to get rid of the other views, they're already good with that. Yeah. It needs to be true.
Thanks. So what is nice is actually in the upcoming Elixir work program, there is a dedicated activity to work and improve the EDAM ontology for specifically metabolomics, proteomics, chemical analyses, and a little bit of imaging as well. So there should be more terms and things available.
That would be amazing.
Over the next years to actually annotate the tools and to drive this like tool discovery. So this fits nicely together. And yeah, also the option to add different ontologies for the annotation as well. So
that would be awesome. Yes. With the ontologies, let's say on main, we already don't have many tools tagged with those. And so that's always been a pain in the past. So that obviously makes the search a lot more powerful. So that'd be very cool.
Yeah, our next speaker is going to be Marius. So we're just setting things up. So it might take us a couple of minutes.
Hi, everyone. So I will talk briefly about user-defined tools, and I think I'm going to go pretty fast. But the main thing is that we want to open things up, and at the same time, we still want to adhere to the core Galaxy values about reproducibility. From users to tool authors, I mentioned this, so we want to lower the barrier and we want to grow the community. So what is the problem? Why is it like a whole procedure to bring a new tool? Well, the tool is basically arbitrary code, and that's not just the shell command that gets executed. There's the templating phase that is in Cheetah. So if you look at this, you can execute normal Python code here. So you could, for instance, read a database or write to disk, and that's something that is a powerful feature if you trust whoever has written the tool. But if our goal is for anyone to come and bring a tool, then that's a no-go. And so how do we deal with this? Through curation. I mean, one of the reasons tools are submitted to like tool repositories like the IUC is that there are reviewers we trust. They look at the tools. They make sure they make sense to users, but also they have a look at like, is there maybe a way that you can break out of the command? Is there anything bad going on? So it is a high bar and by design, but I don't think you need it for everything. So for one-off exploratory type of thing, that's not great. And also if you have a lab meeting tomorrow and you want to just bridge something in the middle, that's more effort than I think is needed. So what we're proposing as the answer there are user-defined tools, or I think we sort of abbreviated to UDTs. And I think, yeah, I mean, it looks a whole lot like XML if you abstract away that it's YAML. The fields are very similar. If you've written an XML tool, you probably understand what each of these things is. Yeah, and the key part here is everything has to be containerized, and there is a JavaScript-based expression language inside here that is safe and can be executed and does not give any sort of permission issues, as is the case with Cheetah. And because everything is like fully typed, there are pedantic models behind it, things are very safe, but also convenient. So we've embedded Monaco, which is like the rendering, the open source rendering engine of VS Code, into Galaxy. That's available here. And one of the things I wanted to point out is that it actually knows what each thing is in the command line. So if you've ever written a tool and you've referenced the wrong parameter, you'll only find out once you start running the tool. That's something that's very hard to check. And if your tool is complex, it's even for an expert not easy to spot. So this is one part of why we're coming up with this new syntax. So yeah, why do we build this? We want to iterate against the real thing. I think that's very valuable because getting a tool or a tool update out is kind of hard. You have to write the XML, you have to build a container, open a PR, wait for the review. And that's not even how do you get the tool actually onto Galaxy, because you, as a regular user, are also not allowed to do this. And that's maybe a little off-putting that like you're stuck in this middle of your analysis, maybe because if 80% of your tools are there, that's great. But when you have a 10-step workflow, that's not enough on average. Yeah, and so that with user-defined tools, we can turn that into a bit of an interactive loop. So it goes very fast to answering the question, is this the tool I want? Because you can try it, you can look at the output, you can change it. Because we have this strong schema associated with it, and I'll show this live, there's a much higher chance that you get the first attempt correct. And if not, or if you need to tweak it, it's very easy to edit, rerun, inspect, and do it again. And then finally, you can also test against the real resources, because you don't need to pull down multi-gigabyte input files, or if your tool needs a GPU, you don't need to bother Nate or Björn or whoever else to allow you to run your recently written prototype of a tool that you don't know if it even works. And I think an interesting point here is that we started doing this before agents were really a thing. But I think agents need this even more. And we saw this also in the Galaxy Live presentation, where the agent looked at what went wrong and then fixed it by creating more tools. Yeah, I mean, I mentioned if you need GPUs, there is a language to specify this. And then admins can decide how UDTs are allowed to access things like GPUs. So that's actually a real example from something that Anton built using Orbit. So this isn't vaporware, it really exists, and it's very fast. Yeah, so LLMs write great throwaway code. I think that's the core of what they do. That's what they're really good at. And for everything else, you need to put the guardrails on. So I think everyone, or a lot of people, are at least generating analysis code with an LLM, and some people even call that reproducible, but it's not really. I mean, the main problem is that the output is ephemeral. It's like maybe a chat message, a copied cell. What I've seen often is hard-coded paths, which, yeah, I mean, that doesn't really work if you need to run it somewhere else or in the future or in 6 months. And I think user-defined tools are a good place for that, actually, because it forces writing of structured inputs. There are the type parameters available to look at, and the requirement of having a container available makes it much more likely that this tool will run in the future. And because the inputs and outputs are typed, it's also very easy to embed this in a whole workflow, so you can go start to end. Yeah, so let's not write it by hand. We can assist a small little demo of how this actually works and looks like. Yeah. Yeah, so I'm at the Galaxy test instance, and I should make things a little bigger. Yeah, so we got Galaxy AI these days now. And what I'm going to do is, like in the live demo, we built the box plot with Orbit. But for Orbit, you need to plug in either your commercial API key or your access credentials to an open model. And the nice thing about Galaxy AI is that it's available to everyone. So yeah, so let's just ask it to use ggplot2 to make a box plot from tabular file. The user should be able to pick a grouping column and a numeric column, and then a little hint, because those models are not quite as good, to put the script in a config file. So then what happens is the task gets sent off to the router. Danon mentioned that. It detected that the user wants to create a custom tool, and then it sent it off to the next agent that's going to do a first pass of the tool. And unfortunately, that's going to take a minute or so. And this is actually GPT-5 Mini. So it's a combination. This was an open tool. This was a commercial tool. So you can see it generated the first draft of the tool, and then it looked at the draft of the tool to find a container, because so yeah, we got a bio container here. We got a mult container actually, because there are multiple dependencies in there. I think there's an argparse and ggplot2 itself. So then you can save this and you can run it. And it's going to work fine, but in the interest of time, I just wanted to say, because I've been making this point, that you can plug this into a workflow. So these are the tools I generated earlier. They're part of a workflow. You can download this and explore this, and you can rerun it, and it'll just work. Yep. And so here's the box plot from that. Okay. Okay, so we've seen that Galaxy AI wrote the whole tool. Type hints, linting, everything is there. It's reproducible and trustworthy. The missing part we have to talk about is how to converge, because the freedom of create has one big problem, that's the duplication. We don't want 100 users building their individual copy of the tool that everyone is building. But I don't think that the fix is not to do this kind of custom tools that you can use. It's instead to provide a path to converge. So you can already share them, you can export them to disk, they behave like a normal tool. But what we need is this kind of graduation ladder where you go from, this is my personal tool, I worked on it, it works now. Maybe you share it through a workflow, and then you put it maybe on your personal GitHub repository, you publish it. At this point, it's able to be used by other people. And then if this is like a very popular thing, we could contribute it back to the IUC, and not all of these are necessary parts of the pipeline. So right now, access to those is an administrator decision. There's a group that an admin can add you to, and then you get access. It's closed for now, but I think I got Nate to agree that we'll be opening this up soon. And if admins are not comfortable with allowing users to, I mean, they can still come with arbitrary code that might be inefficient. If you're not comfortable with this, we're also working on bring your own compute. So then perhaps one story is that your own tools go to your own compute. Yeah, so that's coming to a server near you soon. Here's a little thank you tool. And then finally, I'm hiring. So if you like this kind of power user direction for Galaxy with user-defined tools, workflow, screen compute, bring your own compute, speak to me. So yeah, thank you.
Hi, Marius, great talk. Are you suggesting that IUC should accept the new syntax, the user-defined tool?
Eventually,
yeah. More of translating it to the XML?
So I think my preference would be that we go with YAML, just because there are more things we can validate, and they're nicer to write. But there are some features that we didn't build in because we don't actually like them in XML. So we have to find out exactly what set of features we need and want. So that's a community discussion. I mean, I can make that decision. But it's also very feasible to turn them back to XML. They are all turned into the same tool object in the end. Translation is likely possible. And there might be like a hybrid where you can use the safe JSON, JavaScript templating inside an XML tool. I mean, these are all potential options.
So thank you. It looks really, really cool, and I can't wait to test it. So in our case, we had a need for user-defined tools that could also have groups associated to them, like role-based access control on the tools. Is that something you might consider implementing in Galaxy at some point?
So what is now implemented is role-based access to the feature itself. That's what it's gated on. it's very easy in a way. You just remove the restriction. I mean, it's not that it's not possible. We put the restriction in place that you can't do it because we don't want like this sort of like the tool only lives in Galaxy and like technically it's possible, but I would rather that this goes like once it matures, it goes on GitHub and collaboration happens there because I don't think we would want to make Galaxy GitHub because that's a big task.
Yeah, I understand. It's I don't know if I was clear in my question about maybe the role-based access not being necessarily on the tool, on the creation part itself, but on the actual tools. Like if you want to create a tool, but just for your team, you don't want to publish it to everyone.
I would still say publish that first, like once you start doing it with multiple people. But the infrastructure is split. We can split it by creation and by running. So you could have a different pool of users that are allowed to create and a different pool that can run. It's doable. It's more of a question of like, what do we want to be the best practice?
Thank you very much.
Hey, Marius, excellent talk. Thanks for the feature. So I think we have briefly touched on this a long time ago. So security considerations when it comes to UDD. Does an admin can configure what containers are allowed and what resources are maximum allowed if it's not paired with BYOC, for example?
Yeah. So right now you can do these resource requests and they will just satisfy in general what is available on a destination. So we're working also on pools where like you can say this user gets this kind of pool. The pool could be for user different tools or in general, and then you can mix and match. So you can say, I mean, you have this allocation of, let's say 128 cores and this much memory over this period of time. And then in TPV, you would set that up. Right now, the agent is heavily biased towards biocontainers because we said it's got to be a biocontainer. But the feature itself would work with other registries. And again, you could restrict that in TPV, which is sort of becoming the go-to way to manage resources on large instances. And then maybe on small instances, it's maybe not even that important because you probably know everyone.
And we now have the final speaker of the session, Natalie.
Hello, everybody. I'll give the last talk of this session. My name is Natalie Kucher. If I haven't met you yet, I would love to, so please feel free to find me during this week. I'm a project manager, so my talk will be a little bit more high level about a roadmap that we've developed for the Galaxy ecosystem. There's asterisks next to the first, and I'll get into that. So for my talk, I'll set the scene, how Galaxy is organized and how it operates. We'll talk about the question that we're trying to address with the roadmap, how we went ahead and developed it, and what came out of it, how we use it, what went well, and what can be improved, and what we'll do next. So to set the scene, Galaxy has been around for over 2 decades, and it's very distributed. There are a lot of people doing a lot of different activities across a lot of different time zones. So in a nutshell, useGalaxy.star are our kind of certified instances that meet a certain set of criteria. For useGalaxy.org, we call that main. That is run by 4 labs in the US with many contributors, of course. Everybody's working on that together worldwide. But that just is a little bit of a glimpse into the ecosystem of just how distributed it is. So of course we have Europe, Australia, France, and recently Canada. There are also a lot of other public and private instances that aren't part of this .star network. And you know, as people are doing these activities, it's important to think about governance and how it's all organized. So thanks to Bjorn, Ross, a lot of other folks, we have this governance structure that includes the executive board. So those are the folks that run these critical instances across the world, including representation from these different groups like the technical groups, the technical board and the working groups, the research, which is the community board and the special interest groups, and the GTN that runs the training. So as we have this very distributed ecosystem, a question we have is how do we know what we're working on and how do we decide what we do next? So classically, a roadmap is the way that we would organize these activities. And as we think about the roadmap, there are various types of inputs that would go into it. We have PIs who have acquired funding to actually do this work. There are projects in the US that include these instances, but globally as well. People who bring in funding, and we have these commitments to our funders to develop the Galaxy. We also have developers. These are the people who are day in and out in the architecture and the infrastructure, who know the needs to modernize it, but also know how to implement these technical needs. And then we also have the community, the people who are using the platform for their research every single day and who have real needs that we want to represent on the roadmap as well to make sure that it gets done. So the goal of our roadmap would be to track the major activities that are going on across Galaxy. Here are some objectives. We want to learn what everyone is doing. Things like GCC, where we get to say, hey, that's a really cool feature. And also broadcast that beyond our Galaxy community to the world. We want to coordinate these activities across the teams. Is someone else working on something that I need? Let's be sure that we track that. And of course, tracking our grant deliverables, the things that we promised we'd do in our grants, we want to make sure those get done. So Bjorn, Ross, and others who are part of the exec board conceptualized this governance model and creating a roadmap and a process that would happen with that. And there was an attempt, which I'm not I didn't present on last year, but at GCC 2023 in Brno, Gareth and I started working on a process to put together a roadmap. There were some successes from this process. We had a single document, Google Sheet with a lot of tabs, that recognized all the major work and goals across the major instances. And with the help of Gemini, 3 years ago now, we began synthesizing these activities to summarize them into high-level objectives. But there are a lot of lessons learned in that process too. When you have lots of inputs, you have lots of cleaning, just like any data science problem. We also struggled to capture some very well-defined activities, and we had this Goldilocks problem of this thing is too small and this thing is too big to put on here. That made it too high level to make it actionable. So we decided to go a little bit smaller. And last year, we just decided to dive right in on the US side. So in the fall, we started a GitHub project where I worked with the PIs and the developers to add activities from our grants, the active work that people are already doing, and the near future projects that people had planned over the next year. We had a fall team meeting virtually where we went through that roadmap line by line, and we assigned the items in GitHub to people when relevant, and we started to increase the visibility on the activities. We came back at the beginning of the year to prioritize. So the PIs and the technical board, which are the organizers of the working groups, by the way, we prioritized these items from 1 to 4, 1 being the highest priority, and added quarter assignments to try to spread things out throughout the year, but also capture, what is the scope of these activities. And now we've put it into action. So just a glimpse of what's in the roadmap. You can access it live at gxc.io/roadmap. Here's a screenshot of it. There's a lot of active work that's going on from what's been added there from last fall. So at the team meeting, when we all reviewed, there were 55 issues, but now we're up to 72 total. There are 17 that we called complete. Those are totally marked off and done. And then there are 9 that are this thing that we've called V1 done. It's like, it's great, it's done, it's good enough, but it could be taken to the next level of completion to make it really polished. And sorry, I know today's not May. So an overview of the roadmap and what's in it. Just some charts here. At the project level, most of the activities that are on the roadmap are represented for work in Galaxy as a whole. There are some activities for our US specific projects that are represented. But there's lots of activity that still needs timing and prioritization. So that a red part of this bar chart is no quarter. And then across the teams, I would say we have decent distribution across the working groups, and everyone's making progress on the work there. And finally, for the priority, there's a lot in this number one bucket, which means, is the roadmap focusing on things that are most important, or do we assign everything a number one priority, and is that a problem? And then this final chart, the progress on the priorities, I feel like is decently distributed. So I feel like we're doing a good job there. I won't spend too much time on this slide. This is a sampling of some of the roadmap items within the different categories. The blue is what was in that big Galaxy bar on the top left. It's organized in the working groups and a couple of these other groups. And then the other colors are these independent projects that we have going on in the US. So these range from very specific platform improvements, modernization of the infrastructure. We have an item that's called Make Galaxy AI Ready, which is also kind of vague. And then, we have things that include outreach. So the NAR paper, attending various conferences and outreach, and then even things like integrating support for GA4GH standards and bringing in new tools like Logan Search for BRC analytics and so on. So reflecting on this process, I think we've had some good feedback. There's been a lot of positive reception in the US team, which has been where a lot of this activity has been focused, and that it represents activity that's pretty spot on for Galaxy's pace of development. But the scope of the items need refinement. Again, that Goldilocks problem that I mentioned, is this something that's like aspirational, or is this something that we could do tomorrow and it'll be done? So trying to make sure that we do a little bit of refining as we put together the inputs. And then some of those vague issues that need more definition, like make Galaxy AI ready, that means something different to every person. I think that's part of Galaxy. There are definitely some gaps that I want to point out. As we just dove into this process, there wasn't a big part of the effort where we got input from the community. Like I mentioned, our global community, people who are involved in training, and then, definitely the scientific community. This is something that we would want to focus on in the next iteration. This also doesn't reflect all the activity that's happening on the Galaxy core. I've heard people say anywhere from like 20, 30 to like 80% of work is represented. I don't really think that that's an issue that not everything is on the roadmap, but it's a worthwhile discussion of how much should be on it. And then another gap is reporting out more widely beyond just our US audience, that we have these biannual virtual team meetings, and then GCC, of course, and our release notes, but there are definitely a lot of opportunities to communicate more broadly. So on the horizon, we'd welcome folks to contribute and help us expand the 2026 roadmap to be more reflective of what's going on. We'll review it at the end of the year and talk about a process for the 2027 roadmap that I hope will address a lot of the gaps that I talked about on the last slide. And finally, we'll really focus on getting input from our broader groups, synthesizing the items on the roadmap into more tangible pieces. And then again, going through this process of prioritizing, assigning, and setting the quarters for things so we get through everything that's on the roadmap. So finally, to summarize, we talked about how Galaxy is organized and all the various inputs that go into a roadmap, what we got out of that, ways that we would want to improve it, and how we'd want to continue this activity into 2027. So I'd love to acknowledge Michael Schatz and our lab, of course, the PIs in the US that are contributing and getting us all to be able to do this work, the technical board that's been really involved in the process of the roadmap, and the exec board, including Ross, for talking about the governance. So thank you, everybody, and I'd welcome any questions or discussion after the call.
So I had a look at so the Goldilocks problem is definitely real. But I mean, one of the things that I've struggled with is translating what I'm picking up from my user community into the right size of actionable requests to the Galaxy community. I don't have a huge amount of funding myself, but I do know what people kind of need and find useful. But it's not on the granularity that the current roadmap operates. So any ideas there? Because obviously there's like, must do everything, including my dishes. But yeah, so I mean, what do we need to learn I guess, as people communicating to a project manager like you in terms of, helping to actually turn ideas into action?
That's a great question. I think that reflects a lot of the, on my second slide I had, there are over 100 instances that are public and private, right, that are not part of this usegalaxy.star or necessarily represented in the exec board. I think as much as we can try to fit into the governance structures that exist would be a good way to make sure that those needs and that information bubbles up. So I would say maybe the special interest groups and the community board could be a good place to plug in as part of the technical board. And then even myself, I'd really love to get more connected with the community board to try to filter and collect the user's needs and make sure that that's something that's recognized. But yeah, things that are kind of bugs and paper cuts wouldn't necessarily be represented here. But I think that's kind of the project management struggle of how do you represent the ongoing things or the things that do take a lot of time, even though they're not, flashy enough to maybe make an item about them. Thanks for the question.
Yeah, I don't know, Ennis, do we have time for any more questions? I don't think there's lunchtime. So okay, it's lunchtime now, so probably not. So thank you again.
Thank you.
With the ultimate aim of leveraging that shared identity to do something better in both of those services. So what did Galaxy Australia look like before, as we started this process? We had 50,000 users. At some point in the past, we had turned on email verification, which meant at some point we didn't have email verification. So we were fairly confident we could contact 30,000 users. We're maybe less confident we could contact the other 20,000. We had username issues and we had duplicate accounts, both duplicate accounts inside Galaxy and duplicate accounts between Galaxy and the data portal. And finally, we had a prior attempt to manage identity through the Australian Access Federation. So we had quite a complex scenario to start with. And the principle which I really drove for the team is act on our users' behalf instead of asking them. And it can sound a little bit dogmatic, but the idea is we can't contact what you'll see on the next slide, 5,000 users with username syntax and say, please do something with your username. None of us are ever going to respond to that email. Can we do something for them to make their life easier? So one of these, and thanks to Nguyen for this work, we had 5,500 users whose syntax for username didn't make sense. It was ... .. It was 128 characters of nonsensical string. And it's broken down here on the graph on the right. Invalid characters has dots, has spaces, too short, too long, etc. Interestingly, all bar about 219 of these cases, we could take a proactive measure to change users' usernames. So we did this for them. And when we used Galaxy's internal notification system to tell users about their username change, we accepted that some users might have a disrupted login experience, but interestingly, we didn't get any tickets to that effect. For duplicate emails, actually, again, out of 50,000 emails, we only had about 314 emails that required active management. So I had a lot of emails that had spaces and other things that were inactive. That's fine. But I wanted to show this really just to give you a snapshot of what we tried to solve. And this was manual. So thank you to Igor from our team who literally went through all 314 accounts, picked an account, merged accounts, contacted users. It was a mess. And the example down the bottom is sort of what to do. We have the same person with upper lowercase insensitivity. Do they have data in both accounts? How do we merge? How do we contact them? It was not an easy task, but we got through that. And we had this category of 2,000 accounts of people that had accessed via AAF, which I know many of us have an equivalent system around the world. So it's an organized authentication and identity management system. These people were interesting. It's great. They'd connected to Galaxy through their university, which meant that they actually had no idea what their Galaxy password was because Galaxy never kept it. So our entire concept of moving them to a new service and asking them to re-sign up as a validation strategy fell away because these people didn't know their password. In the end, all we could do is email them, which was pretty painful, but it's what we did. So that was all thinking about our users. Then under the hood, there was a whole other piece of work thinking about how do we actually unify Galaxy's OIDC to allow us to make changes to Galaxy and simplify Galaxy again, thanks to Nguyen and Marius from our team that really championed this work to pull Galaxy into a place where we could leverage its OIDC functions. What that actually meant is that Galaxy could accept a new login strategy. It also meant that we were turning off Galaxy's inherent login and registration strategy. So we're splitting login registration from user management. What that looks like, I think many of you are familiar with the slide on the left. That's a pretty typical Galaxy page, email, password, push a button, go into Galaxy. Now looks like what it looks like on the right with a new Biocommons access page, essentially asking the same information. So we're not actually asking for more from our users. It also means that the manage information section on Galaxy Australia is now essentially gone. You're now just presented with your username and you're redirected to the Biocommons access portal if you wish to do something to your account, which is great. If you want to do something to your Galaxy account, what's really nice is you can easily access other services. And this is what it was always about, is connecting services. It wasn't just about picking up and moving everyone from Galaxy. And then at some point, we thought we were ready. So we had very few people in the middle on a big red button and a lot of us sitting around the side looking relatively nervous. And a migration involved doing a lot of things, involved a lot of, I guess, attempting, and I use the word attempting versus succeeding, attempting to contact our users. So banners and alerts are great for people that come to Galaxy, but if they don't come to Galaxy within our period of alert, they're never going to know. So we put a lot of information into communication. We built a whole new help desk around managing access. Then we had a preparation for the day, which includes things down the bottom here in green. Put Galaxy into maintenance mode. Now this, I will confess, is written by a different team who didn't realize Galaxy doesn't have a maintenance mode. So we went live and we did live testing, which was a very stressful hour or two. With a rollback strategy, we did not need to roll back. And we ultimately had a migration checklist. So we had to pick up all 50,000 users. We had to bring them into a new Auth0 database. We had to do that at the rate that Auth0 would allow us to ingest via API calls. That was rate limiting. So we did it actually over quite a few days and then just did the delta in the last day or so. We went live and we waited and panicked and watched and hoped for the best. And we got there. So this is a slightly older graph, deliberately so, because the numbers just keep going up. So there we are on the 29th of March, and we went live and we immediately had a number of accounts active that jumped very quickly over the next week or so. Data wasn't collected the whole way through. I highlighted the Galaxy Training Week because we saw another spurt of registrations, and that was the kind of registrations we were concerned about, because the Galaxy Training Academy, a great event, but sometimes that's people that only come once a year to our service. How did we contact them in the previous year? We couldn't really. They came back, they re-registered, and that number has continued to grow. What I don't show on this graph is this is migrated users. So these are users that previously had a Galaxy account that are coming into our service. There's almost a one-to-one relationship to new users coming on board into the service. So did we achieve our access? Did we migrate our users? Did we lose a few hairs? I know I did. So yes, we did. And I'm going to show some of this in the community talk on Wednesday. but our users within Australia now have a clear and simple way to register and log in to 1+ services. So we're currently at 2 services. We'll bringing a 3rd service on in the next few weeks. What can they do with that? Well, the first thing they can do, and I thought this concept, I know I'm introducing into my conclusion slide, but it's complex. We've come up with a notion of bundles. So not only do you get access to Galaxy, if you are recognised as a member of a community, the Threatened Species Initiative community, the structural biology community within Australia, and by community in this case, I'm meaning a funded group of individuals, not a SIG kind of community, but a funded community. We can actually tailor packages for them so that when they arrive in Galaxy, they may get proprietary access to licensed tools. They might be able to run more concurrent jobs. Their TPV allocation for certain jobs could be bigger or different. So that's quite an interesting concept, and we're working through what that means because in the end, Galaxy is so open that most people can do what they want to do, but we can leverage a little bit more. And what's really exciting in the last week, and in fact, including when I was still flying over here on Friday, users now have a 1-button click to move their data from the Bioplatforms data portal, which again is one of our major national repositories, directly into their Galaxy histories. They can bring in single files, multiple files, collections, and they're not doing that by setting up a repository, setting up a file source or managing a repo. That's handled by that Auth0 layer underneath. And ultimately, that's what we're trying to achieve, is allowing people to get their data from wherever they want in Australia and get it into Galaxy easily. So now we're actually at a happy position, which is now that this all succeeded, what can we do? And I've been a little bit provocative by saying access held by an independent party. And I mean that in the sense that even though access is held within the Biocommons, it's no longer within Galaxy. And that's uncomfortable for me. So with that uncomfortability, which I'm sitting with that, I do have a BOF tonight on what are we going to do with access. If we do trust who you are, what can we do with that information? And I'd love to hear people's thoughts on what it means to have really high-level trusted access in our user identity. Thank you.
Thank you for the talk. You mentioned bundles. Is that a vanilla Galaxy notion, the groups, or is that something that you implemented yourself?
It is something we've implemented ourselves. It leverages the concept of a Galaxy group and role. Okay. It's just designing that up front so that when a user comes from a particular domain, and in our case, we're thinking park rangers and ecologists that want to analyze threatened species, what do they need? What resources do they need when they arrive at Galaxy that might be more bespoke than a generic Galaxy user, which is a dangerous term to realize. But no, it's essentially leveraging Galaxy groups.
Thank you.
Which moved to Galaxy Core from this, or did you, when you mentioned implementation, is it custom implementation or did everything move up? Are there any lessons Galaxy Core can learn from it? Do we need these features as well?
Yeah, you absolutely need these features. No, one of our principles in design was not to fork Galaxy Australia. We've been down that route in the past and it's just overhead we don't need. So changes that were made were always pushed back up to core with the view that hopefully others would benefit from them as well. And I think Nguyen would advocate that a lot of the cleanup in OIDC has been quite helpful for other aspects of Galaxy.
Next talk, also motivationally named A New Star in the Galaxy. We have Pierre at the end. Yep, please welcome him.
Yep, thanks. Sure. Yeah, thanks. So as you will see, we are still a very small instance. So before starting with to describe the whole thing, so the first thing is really to acknowledge the team that is really making this happen. And then I will follow up with a small history leading us here and some contributions that we already did for the Galaxy ecosystem. Then I will briefly mention about the Canadian Digital Research Infrastructure, DRI landscape, and then I will present briefly the Use Galaxy Canada infrastructure, some specific features and quotas, and our usage evolution and roadmap. So first of all, so I would like really to thanks so the ones that are really leading the show. So Carol, our team manager here, with Charles, which is really the lead developer here and user support, and our fabulous John, who's also working with us part-time, but it's really like really highly appreciated. So those guys are helped with other sysadmin from our Sherbrooke University, as well as some other members that are from user support, basically from other universities. I also want to thank our close collaborators, so NS and UN will really help us at first to put things up. And also want to thank really important contributors, so David Moret and Jonathan Lapelle, that were really lead developers and really help us in the development of all of this. So shortly after I started my group, so Guillaume Bourque from McGill University and myself got a grant to develop this GenApp platform project. And we decided to set up 3 major components. So leveraging the Compute Canada infrastructure back then. So the first one was a series of robust pipelines for various genomic applications. And this is still work ongoing, still living. It's called now GenPipes. And it has been used to analyze more than 3 million samples so far. A second component was a web portal, allowing users to spawn a few applications. We got like a modest users, so 500 users over time. And back then we decided to use the CI logon for the single sign-on authentication. So part of these applications, so we got like the Galaxy. So we got about 150 private Galaxy instances. Overall, we had more than 100,000 jobs that were run through these private instance, Galaxy instance. We also had other kind of applications, including data hubs that were used to host UCSC genome browser track hubs. That was really popular at that time as well. And we also were the back end from MetaboAnalyst portal with a really popular tool. But our third contribution was the one that we actually bring back to the Galaxy ecosystem. And actually, that was one of the first that we decided to implement was the CVMFS, so the CERN Virtual Machine File System, which is a tool, as you probably all know, it's a tool, so the way that to distribute the tools and the reference files. So back to GCC 15. So David had a poster and a lightning talk here at the GCC to explain how we decided to implement and use CVMFS to launch Galaxy. And then from 2016, so Galaxy decided to adopt this way to distribute the files and the reference. So, meanwhile, so it was really a heavy process to maintain all these active independent Galaxies. So at some point we decided just to more centralize the efforts, and then we start developing and implementing the usegalaxy.ca portal, and we are in full production since 2025. So the Canadian DRI, basically, so we have like, so this is the DRAC, so the Digital Research Alliance of Canada, also called the Alliance. We have 5, I don't know, there are 5 national sites and about 30 local support sites across the 10 provinces in Canada. So in total, we have about 740,000 CPUs, about 2,000 GPUs, mainly H100, A100, a bunch of RAM, and almost 2 petabytes of storage. In addition, we also have cloud resources, about 40,000 vCPUs, 450 vGPUs, and about 38 terabytes of storage. So the Use Galaxy Canada portal is hosted within the Beluga cloud infrastructure, which is managed by Calcul Quebec, also managing the Narwhal cluster that we'll refer later on. And the University of Sherbrooke is really like 2 hours from Montreal. So Calcul Quebec, so the Beluga cloud is in Montreal and Quebec. So for our current resource allocation for the Use Galaxy portal is about 1,000 vCPUs, about only 4 GPUs so far, with almost 5 terabytes of RAM and 250 terabytes of storage. And we also tap on this Arbitus cloud, which is a cloud from the DRI official site, where we have mainly these infrastructures. So I will not go into the details about too much in the details about our infrastructure, but basically it's really it's using the OpenStack Terraform and Ansible playbooks, yeah, we also being about to set up some Pulsar nodes on Community Cloud, as well on being able to also launch jobs directly in the drag clusters. If you want more details, please come poster number 6 today. So some specific features and quota. So based on recommendations from our colleagues from the Use Galaxy Star network, and also because we were starting from scratch, we decided to run all tools in biocontainers to really ease our life. The single sign-on, as I mentioned, is through CI logon. The Canadian got 500 gigabyte storage. International academic users about 250, and all other users are just having a 5 gigabyte of RAM. Storage, sorry. So we also have a storage backup on tape using the Calcul Quebec infrastructure, and we also have the possibility to integrate integrate the Galaxy with DRAC HPCs if you are sponsors, because this is the HPCs you have to. It's required that you are Canadian or sponsored by Canadian researchers. So our usage evolution, so it's still modest. We reached the 1,250 users recently. Overall submitted almost 200,000 jobs with about 45 or 50 terabyte of usage so far. So about 5,000 histories, 200,000 data sets, and we are really actually having about 7,000 tools right now. So our roadmap, so we just recently launched or installed the V26.0 update. That was one of our objectives for June for the next months. So we want to ramp up the compute and storage capacity, because the numbers that I just shown you are the one that we will have actually over the next month. So it's not yet in full production. As I mentioned, we also add some Pulsar capability in the cloud resource with vGPUs on the Arbitus cluster, as well as some HPC clusters with the Narval cluster that I mentioned before. We also want to improve and work some monitoring, so the node health check systems, so SLARM triggers, node service states as well. So during the next, the fall, so we also want to enable more features. So we don't have yet the interactive tools. So this is something that users are really asking, and we really want to give access to really soon. We also want to connect user remote files. So some of the features that you guys probably all have access and use. We also want to implement some scratch storage. We also have like this periodic purge of files. So after a retention period, so I forgot to mention, but for the Canadian, it's about 500 days, if I remember correctly. For the other academic, it's about a year. So we want to implement the periodic purge. So after a certain amount, so histories might be deleted if it's not. So users will receive an email as it's done in Australia, if I remember correctly. We also want to improve the resource allocation with the TPV, so early 2027. So we want to expand capabilities. So we want to implement the dynamic resource scheduling, and we also want to start working to bring back again this concept of the private galaxy, but now in secure environment. So that what we call the SD4H, so secure data for health, which is secure cloud computing infrastructure, also managed by Calcul Quebec as an infrastructure as a service. And recently we have this initiative, which is the PCGL, so the Pan Canadian Genome Library, which is the equivalent of the dbGaP in US or ENA in Europe. to get, like, for instance, 100,000 whole genome sequencing that is coming up. And so all of this is within this secure environment. We also want to basically add some capabilities. I mean, so adding the capabilities to launch private galaxies to analyze these data. So basically, our inspiration here is the anvil that Ines will talk more about in a few minutes. Another really important task that we ask ourselves is really the continuous training and outreach. So this is something that we really want to be more active on it for the next year or so. So that's it. So if you have any questions, so come please at poster number 6 today.
Thanks for the presentation, and it's great to have another Use Galaxy Star. The users that you have now on the platform, can you say like which profile are they? Are they mostly just testing the platform and using it as training? Do they actually process real data? Are they bioinformaticians? Do you know?
We don't have that many information, but I would say that if we look at the logs from the active, so it's about the third or something like that that are really active over the last 6 months or something like that, and they are recurrent usage as well. But we do use this platform for training as well, so we suspect that many of them are just coming for the courses and then never come back, or a few of them are coming back. But yeah, so. And mostly are biology. From the tools usage, it seems that most of them are really from life sciences background so far.
Okay, thanks.
Any more questions? I actually have one, if you don't mind. So free resources for international academics. So how do you tell when someone is an international academic?
Yeah, so actually, because from the CI logon, so basically you just log with your own institution credential, and then you can have access to the resource. Is it your question, or?
So just trust them being academics, even though they might be staff.
Oh yeah. So I mean, so if you have an institutional account, this is yeah.
Thank you very much. Thank you for the talk. Our next speaker is Nate Brower. I don't know his talk, but I assume it's about scaling. It's always about scaling with Nate. Please welcome Nate.
Thanks. Yeah. So I'm going to be talking a bit about the efforts and recent developments in scaling Galaxy for usegalaxy.org and how that applies to you. So when we talk about scale, what we're talking about on the scale of usegalaxy.org at close to 500,000 registered users, we get about 5,500 a month on average signing up, and run somewhere on the average of 700,000 jobs, topping out over 1 million jobs per month at this point. So there's a lot going on. In addition to just those counts, the scale of jobs, the amount of storage used, the size of inputs and outputs, and the amount of memory needed always increases. So Galaxy is easy to run. This has been sort of one of our claims to fame for a long time. You clone the code, you run the script, and you have a running Galaxy server. But when we're talking about scaling, of course, like for a large server, the question is, it's not quite so easy to run that at that scale. So the big considerations when you're setting up a big server, you need a large amount of compute resources, large amount of memory and cores, very large storage usage over time. The reference data, so things like genome indexes and databases and so forth, for the tools they grow, they have to be curated. And of course, there's our security. So if you've ever run a Galaxy server for more than just yourself on your laptop, you probably are aware of these concerns. And even though, very few people are going to be running a very large scale Galaxy server, I promise that there's some stuff in this talk that hopefully is interesting, even if you're just running a regular Galaxy server or just using one. So how would you typically set up a Galaxy server? Okay, you're going to get a large VM to run that server on. You're going to mount some file system where you're going to store all of the data that users generate. You're going to get a cluster. You're going to attach that cluster to the Galaxy server and the storage. You're going to install all the tools. You're going to try to run a bunch of stuff. It's probably not going to work the first time, but eventually you'll get there. And then you have this wonderful Galaxy service that you can expose, that you can allow people to use. And suddenly you're going to have this issue where you need to scale up. But even maybe before you get to that point, there's an issue here because depending on how you've tried to set up a Galaxy server at your institution, you may find that some of these things are not exactly easy to do within your institutional structure. So for things like getting a cluster that you can run things on, having the storage, having it mounted in both places, the cluster and Galaxy, you have some options. You can either just dedicate resources to Galaxy, but that's hard to do. It's expensive. Or if you have institutional storage and cluster and that kind of stuff, maybe you're important enough at your institution to get the IT team to integrate your Galaxy with that. Maybe you, for example, bring them donuts every day and they absolutely love you, or because we're here in France, maybe you give them croissants every day. Either way, if you don't have these things, what do? We actually have a solution for this. It's called Pulsar. Pulsar is designed to allow you to run Galaxy jobs anywhere without that tight sort of integration with IT infrastructure and like blessing from admins and all that meetings and stuff that you'll have to go through to get all that set up. So it's our remote execution service for jobs. It's not new. If you've set up a Galaxy server, you've probably heard of it before. It does have these requirements, and we're going to go through sort of each of these because they themselves sort of have made it not so attractive as a way to run jobs, but actually we've solved a lot of these problems. So, and most importantly, when you run jobs through Pulsar, you don't have to have that shared file system. Your Galaxy server doesn't have to live in this tight cooperation with the cluster and have all that admin thing. So the roadblocks that you might encounter to previously to running Pulsar jobs. So tool dependencies is a big one. When you install a tool in Galaxy, you're just installing sort of the definition of how to run that tool. We obviously don't write software that tools actually run. And so, but thankfully, there's this giant ecosystem, Conda, BioConda, Conda Forge, et cetera. And then the Biocontainers project, which builds Conda packages into containers, which then can be reused. And so then there's this ecosystem of stuff. You can find the image on this repo. I didn't make it. I think Bjorn did. But this ecosystem that we've built to then take those biocontainers and place them into CVMFS, which is a file system that then you can mount up on your Galaxy server and have access to all those tool dependencies. Yeah, that's the TLDR. That's what I just said. And if your package, if your tool dependencies, if you're running some custom tool and they're not already in a biocontainer, it's actually extremely easy to make a biocontainer just by saying if those packages are in Conda already, then you can just have a biocontainer built with them. You just make a PR against this repo on the left, and there you go. If that's not even possible, because maybe your dependencies aren't in Conda or it's something very private, Galaxy can just run a container directly. So that handles tool dependencies. The next thing that we have to deal with is reference data. So we have a project called the IDC. Unfortunately, it's been somewhat stalled for a couple of years. It was very complex and had some issues. I have been curating data into CVMFS, which is the other repository that you can see here, but it's a very ugly shell script. TLDR about this is there is a lot of reference data in CVMFS that you can use in Galaxy today, but we have a BOF on Wednesday to do better at this. So both the previous talk and this one, I've mentioned CVMFS, and I don't want to go into like great detail about this. We have talked about it many times in the past, but just as a general thing, it's a globally distributed read-only HTTP-based file system. So like firewalls don't get in the way. You can mount this thing from anywhere to anywhere. It's great. And in it, we're storing Singularity images from that graph that I showed you. And then all this reference data that we've been curating. And you can take a look at what's in there today. But Nate, you say, I can't mount, the whole point here is we're supposed to be setting up a Galaxy service where I don't have admin privileges on my cluster and I don't want to have to interact with my admins to make that happen because they're not going to do it. And so there is actually a solution for this because the same stuff that makes Docker possible and Singularity possible makes this other thing called CVMFS exec possible. I'm going to try not to say that more than once because it's impossible. But it's a self-packaging shell script that you can just run on any system. And after doing so, it appears as if CVMFS with all of the data and all the Singularity packages are mounted. So you can just run Galaxy jobs inside of this thing, and suddenly all of the stuff that wasn't available on that system appears to be available and is downloaded for you automatically. So here's just sort of what it looks like when you run CVMFS exec. Without it, you're just going to say Apptainer exec or Singularity exec, whatever. And you're going to run BWA. You've got some reference data, the HG38, and we're trying to run BWA mem. Okay, so if you don't have CVMFS, now you can just say CVMFS exec, and then the rest of the command remains the same. And if you don't even have Singularity or Apptainer installed on your cluster, which you may not, CVMFS exec can actually just run that Apptainer directly from CVMFS. So because of this, what it essentially means is that I can log into any system in the world and not care anything about what's installed, what data is available, what the file systems are, anything. It's like I have a Galaxy capable environment immediately inside of that system. Okay, so there's another roadblock for being able to run your Galaxy jobs anywhere, and that's metadata. So after every single Galaxy job runs, we detect the metadata on the outputs of that job. And this can be a very expensive process. So in the traditional sort of Galaxy environment, we just ship this in with the cluster job. It goes in as a little step after the cluster job runs. It runs on the cluster. It's very efficient. But you have to have that shared file system. And in a Pulsar environment, that was always difficult. But now we have Celery, which is a distributed task queue. It's been part of Galaxy for many years, and you can use this to offload that process onto a separate worker. Basically, what it means is that a lot of the complication of actually being able to run jobs with Pulsar is gone now because of that. Finally, there's one more step, and that's how you communicate between a Galaxy server and a Pulsar server. And traditionally, this was done with RabbitMQ. It's a message passing server. And for this, you had to have it running on a server somewhere and open up a port for it. And if any of you have ever dealt with trying to get your IT to open up a port for you, and you're saying, oh, I just want to expose a message queue to the internet, it's totally fine. It's not totally fine. They're not going to do that for you. But what they will do is they might open up your Galaxy server, and so we can just sneak in behind that and put an application called the Pulsar Relay in, which does this. And then that solves that communication problem. So the same proxy server that proxies your Galaxy server can also proxy the message passing between Galaxy and Pulsar. So as a result, now you can finally run your jobs anywhere with no administrators, no special privileges, no special ports open. And yeah, pretty awesome. So 3 more things worth mentioning in this whole scaling picture. So we've had 250 gig quotas on usegalaxy.org since forever, but that's way too small for a lot of even just a single analysis. So now we have a terabyte of storage that you can use for 30 days. And that will probably even increase over time. But basically, you pick this scratch storage. You can move things in between scratch and permanent, but after 30 days, it goes away. We have now the ability to scale onto a cloud. We've been doing this for years, but only recently, some of our close partners, such as the Vertebrate Genomes Project, have gotten their own allocations, and now we can scale onto the cloud using their allocations, but all integrated with our environment. And none of this would be possible without the total perspective vortex, or TPV. I'm not going to talk about it. It's been presented before. Nuwan had an excellent talk on it in 2022. But this is basically a meta scheduler for us that can just send Galaxy jobs wherever they can possibly be run. And that's important because this is what the useGalaxy.org infrastructure looks like now. I've been using this slide for years, so apologies to everyone who's seen it before, but I can't help myself. Everything on the left column there is basically the only fixed resources that we have. So we've got the VMs that run the Galaxy servers themselves, and then we've got a small fixed cluster called Cyclone. And then everything else from all the way on the right is like HPC systems and cloud systems and so forth that are on the other side of the country that we have to integrate with. So, and this is all possible now. In a way that it wasn't in the past. So before, when one of these systems we'd get access to it, it would be a huge amount of effort to get that integrated. Now I don't even care like what the system is running, what operating system, anything. It's like one day, and we can get it integrated and running jobs from useGalaxy.org. So one more cool thing that came from all of this work. So I mentioned briefly Pulsar Relay, which is this thing that takes the place of the message queue, but this actually enables us to do bring your own compute in a very fun and interesting way. So my boss, Anton, he likes to collect hardware that he finds lying around the floor from researchers who have left. And so he recently built this little cluster, and the question was, can we run jobs from useGalaxy.org from here? And it turns out, yes, we did like basically a proof of concept experiment last month where via the Pulsar Relay, we do this whole OIDC auth flow where you ask it, okay, generate me an account. You do that in your browser, it connects to useGalaxy.org. There's definitely not a small step in there where I have to do something manually, and then you can run those jobs. All right, that's it. Thank you, everybody.
Hi, so the question is actually about the Pulsar Relay. So, I mean, basically, I haven't tried it yet, but I was always wondering how resilient, let's say, or how it works when there's a connection drop or something, because with the RabbitMQ setup, then, I mean, obviously, as long as when you launch a job, it will be dropped in the queue, and then at some point the Pulsar endpoint will pick it up, right? Yeah. But for the Pulsar Relay, it's basically, I don't know anything. So for me, it's not clear how this would work in that sense, or what would happen if the connection drops.
Yes, actually, I mean, Marius can answer this better because he actually wrote it, but the design was built for that, for fault tolerance or that was a part of it from the design, right? So like if either end of it is not there or the relay itself, Marius has shared me, yes, he's nodding yes, that it handles that, right? Like the messages wait to be delivered until the service is available.
How does it work internally? Like, is there a queue on the Galaxy side, and this queue gets sent over a queue on the other side, or how does it work? I mean,
it's just the Galaxy database on so Galaxy and Pulsar mostly don't change. It's just the interface to how to pass that message. And then on that side, I think it's just Redis, right, where it's dumping that stuff into a Redis database.
So the problem with RabbitMQ is that's an asynchronous protocol, and there isn't really a baked-in way to do acknowledgement that the message has been delivered. And in theory, it works, and sometimes it works also for Galaxy, but most of the time it doesn't actually work, because people will say, my job's been running for 2 days, when actually the message has just been lost somewhere. But because this is now a synchronous protocol, the client knows the message didn't get out, I need to retry. So it's a much simpler way to deal with asynchronous communication.
So please welcome Michelle with her talk about the Global Galaxy Registry.
So my name is Michelle, and I'm on the Galaxy team at Hopkins and in Mike Schatz's lab. I'm a software engineer, but recently I've been tasked with looking at a number of challenges that are probably familiar to most of you related to Galaxy instances. And this talk is called the Global Galaxy Registry. So I'm going to start by talking about some of the past instances, issues with the global Galaxy instances, and then going into the present state of where we are today. Can you hear me? Okay. And then we're going to talk about the future of where we're going, maybe. Okay, so previously, and if you don't know this, because it's been said a few times already, but Galaxy has, over the course of time accumulated almost like 200 global server instances around the world. But before that, there was, when Galaxy sort of launched as just a single instance, .org, and then with sort of in a middle stage of a federation emerging through .eu and this sort of like partnership and collaboration with what Bjorn had started. And then sort of moving that more now into recent time where we have sort of more of a explosion of like instances and around the world. So we have various subdomains in Australia, France, Belgium, Canada, Norway. Sorry if it's not listed here, but tell me if it is not listed here, because then I can add it. So with all of that explosion of servers around the world, there were some unintended consequences. And some of that is down to coordination, and some of it was a fragmented information, incomplete information. Some instances have, maybe different versioning information. And so then sort of in the very, very recent history, there's been more of a consolidation of instances, particularly smaller instances, being absorbed into larger instances, which is fine. But so that's why the number has sort of fluctuated over time. So in about 2025, the Galaxy Executive Board, of which I'm a member, said, okay, let's see if we can try to resolve some of these issues. We need to know who these instances are, what the instances are doing a little bit, and then connect everyone together, but mostly connect them to core Galaxy and see how we can assist them. There were some use cases that kept repeating. So looking at the benefits for larger Galaxy instances, users who need to move their work between instances. For example, moving histories between instances, which is something you can do, and there's an FAQ on that. But it was a common issue. And then for smaller Galaxy instances, there was a challenge of how to address the sort of these specialized data set needs. And then if you're running a large project, or actually if you're running a small project for over a long period of time, having your own instance running is something that is very beneficial for a smaller instance like the VGP. Also, there was this already kind of proliferating little groups that were trying to solve this issue. And so you have GOATS, which was maintaining the page on the hub. And then you have like Julian's Galaxy Cat, which was awesome, where you can search by reference genome. And some work Dave Clements had started. The devs had done a lot of metrics. Of course, Bjorn had started something, in this case, a map. And Mike even created this own kind of like super duper version. That didn't quite solve everything. We still had some figuring out to do. We had these sort of different types of scenarios that we had different users, like a tool hunter, someone who's really just looking for a tool, a data person who has very specialized data that they need, and somebody who's like a super specialist, getting back to that whole project-based example. Okay, so with a little configuring and a little searching on the Git history logs, you could kind of go back into Git Galaxy Hub site and the Galaxy Hub repo and just look at when various instances added their own YAML file to Galaxy to get listed. And you can kind of see how the Galaxy instances grew over time. It just gives you a very rough idea. And around 2021, you can sort of see that consolidation period where things kind of, small instances get absorbed in the larger instances. And in this slide, it's just a little bit of a breakdown by country. You can see, EU has an amazing presence. And some of these are also domains, so it's a little distorted, but it still gives you an idea of where we aren't anyway. And some of the things to note in addition is that there's a growing presence in Asia for Galaxy instances and Galaxy use cases. So maybe there'll be a community conference there. And then there's some underrepresented regions that we're not in, like very much at all, like Africa, South America, and the Middle East. So I think maybe there's an opportunity there for like expansion in the global South. Particularly, I know everybody's trying to move to AI, but those areas don't always have access to AI for a variety of reasons. So Galaxy still might be more relevant there. Okay, moving on. So present. So this is a map basically that lives on the hub now, and you can kind of see how the instances are dispersed. Yes, this example is very much centered on Europe, but you know, it's you can zoom in, zoom out, and you can kind of see proximity, see the website, see details on the instance. So that's something that I put together last year, late last year. Also, I put together this, well, actually, this is just an organization issue. This was already around. So this is the catalog instances page where you can submit any sort of instance container that you have. And if you want to join the Use Galaxy Federation or the Use Galaxy.star organization, this is a different form where you can specify a little bit more information like accessibility, access policy. You know, Galaxy has these principles of accessibility, transparency, reproducibility. So to keep it accessible, we need to make sure that registration is open and obviously have like a terms of service. For transparency, we had the code must be in a public repo and the playbook visibility and also reproducibility. You know, we just need participation. So it's all about making things reliable for the user. And because if you do get accepted as a Use Galaxy.star in the Federation, you also sort of become an example for other groups in your region. So they will copy you from there. So we want to make sure everything's set up well. But all in that, there's a lot of information where you can add comments on the form itself. Every situation is unique. Every instance is unique. Every server is unique. Every project is unique. So, you know, if it doesn't quite fit, you know, we still want to know and we can try to make it work because we would love to have you as a part if you're not already. So with that and with the Federation sort of connected to the larger Galaxy, hopefully that would be tied into sort of these metrics, which Ines had put together a few years ago, where we can now count how many users we have, and we can also start counting engagements if we want. And we're just looking at very basic engagements. This is not really behavior tracking. This is just looking at, ran a job in a 24-hour period. So some of the changes also that I've added is this is sort of the core metadata we were collecting on instances. You know, platform name, domain, geographic location. However, I have expanded that to include this sort of extended metadata, which is like the tools, the genomes, user support information. Oops, hang on a second. And then the last here is the operational data as well. That's something that I hope to cover more about, like uptime, availability of the instance. Okay, so in that, there is a tier system as well. So we have tiers 1 through 4, where 1 is a global flagship, 2 is a regional server. Not necessarily, it can serve anyone too, but it's really focused on users in that region. Domain, sort of specialist workbenches, project workbenches, and then institutional as number 4. Okay, so to get involved, you just need to submit your instance and we'll help you with the onboarding process. And then from then on, that will create a YAML file, which gets loaded onto the Galaxy Hub repo. And then you can just continue to edit it as you and make changes over time through the evolution of your instance. And then another feature that was in the sort of prior version, but will be in the new version, is being able to search for references like reference genomes across instances globally, and then search for tools globally. and more transparency into what the versioning of those tools are and what version of Galaxy people are running. Okay. Next. Yep. Okay. So this is just talking about the automation components and yeah, some of the versioning that we're doing with the checking and keeping things more reliable. So in the future, I hope that we'll be able to yeah, have a bit more guidance on a researcher, scientist coming to Galaxy and knowing where to direct them intelligently. Also, I think the idea of moving, connecting instances to each other, Natalie Kutcher talked a little bit about that, I guess, and how projects can, who are working on the same things can know about each other and helping facilitate that process more so we can maximize our usage, our resources. And also special interest group alignment. So they talked about special interest group. So you guys who are in the special interest groups have a lot of specialized knowledge, which can be used to then vet various components or tools or platforms. And so leveraging that would be a possibility as well. But yeah, basically bridging the discovery gap and yeah. Okay, so yes, we do hope to have health checks and automation, but I would say probably global expansion is something we should really take seriously. There's a lot of opportunity to combine with like Cabana in South America and H3 Africa, which is a genomics network there. And yep, okay, so I think that pretty much wraps it up. Again, if you're an operator, an admin, or an instance owner, you know, please, if you're not already listed on the Galaxy instances page, please come talk to me, or please, you know, visit one of the websites that you saw on my slide and to get started. Thank you.
Thank you. Initially, I think you said that there were multiple places where you have the different information for the different servers. So for example, on the Galaxy project, there is a Galaxy Maps repository that takes different localization of the servers. I was wondering if it would be possible to integrate also the non-public servers, because if we are running, for example, a server for the university, it would be interesting for the people from the university to know that there is indeed a Galaxy server for them that is not accessible to the public, but still accessible for them.
That's an excellent point. So yes, I think we want to list everything as possible. That might be something that we need to take a closer look at. So thank you. It should be possible technically, but I'm not 100% confident. I'll have to look into that.
Thanks, Michelle. That's actually a super cool talk. And I hope this is a question and not a statement. So I'd like to think that each Galaxy benefits from every other Galaxy, but I also want to service my users. So I would love to know somewhere in your metadata searcher, how many people are having to move their history, say, out of Australia to EU to complete an analysis. Therefore, what do I need to build on AU to keep them working locally?
Yeah.
Maybe it's export histories, maybe it's something, but yeah. I think there's an opportunity for us that are administering Galaxies to learn how to do it better for our local population. So this is super cool.
Yeah, that's probably the next step. Thank you. Yeah.
All right, so we've heard a bit about TPV before. Now we have talk about its evolution presented by Marius. Please welcome Marius.
Okay. Yeah, so I'm presenting this, but actually it's Nuan who is the author, and Nuan is also the maintainer of TPV, and he couldn't be here today. And I registered and probably made a mistake because Nuan was convinced it's a lightning talk, as you can see here. So we probably have some time for questions at the end. Yeah, so let's talk about some recent new cool features in TPV, which stands for Total Perspective Vortex. So TPV is now in production for a long time at the Use Galaxy instances, and it's been a huge improvement over the previous version of it because everybody had their own custom job scheduling script that was hacked together and altered, and whenever that was upgraded, it would fail. So this was like a super important, invaluable piece of work. And then here's where it is at in 2026. So it's it's in production. So more than 50 million jobs have now been scheduled across the 3 AU, EU, US servers. There is a community database, which is a YAML file that you can actually contribute to, that has about 1,000 tools that have specific rules for them, which is probably the majority of tools that needs more than a single core in the 3.7 gigs of RAM that we give to any other tool. It has more than 60,000 installations from PyP in January 2026 alone. And like some of the key things that really highlight its abilities is that we were able to reduce Kraken 2 out of memory failures from more than 190 to 0, and cut down the memory waste. Because TPV is quite flexible in how you express the relationship between the input data sets and the resources you allocate. You can do any sort of math in there. Approximately 10,000 allocation hours are saved per year. Or to turn that around, you could run 90,000 extra jobs on the same hardware. And scheduling decisions are very fast, run in millisecond latency. So that's not the significant overhead if you send off jobs to a cluster anyway. So that's also published now in SN Computer Science. So what does TPV do? I mean, the core of it are these different rule layers that you can stack and compose. And there are 3 main things that are the tools, the users, and the roles. And you basically write rules to associate them. So you can right size cores, memory, GPUs. These are the primary things that you would attribute to a given tool. You can route them through scheduling tags, and there will be an example later. And then you can rank which destination is best. So that allows some meta scheduling to determine, for instance, whether a destination is more busy at the moment, another destination would be better suited. It's closer to the data. There are all sorts of extensions that you can plug in. And the destinations are driven by whatever is actually available, and you can group them and cluster them so that you can sort of virtualize and talk to multiple destinations. In fact, you synthesize the destination, which is your cluster, maybe a different partition on your cluster, maybe multiple clusters. So the improvements since July 2025 is, I think a major thing is validation. So there's now advanced validation possible that's driven through MyPy. We'll talk about that a little bit more. Type checking added and field linting. Because again, if the rule is broken, it's not impossible that most of the jobs will be broken. So it's very important to do as many checks as you can before you even start using the rules. And there is a multi-file config now. So you can, for instance, plug in a shared database and then come in with your more specific overrides for your infrastructure, for your needs. In 3.1, we added tool metadata. So I showed you earlier in my talk that tools can specify that they require at least the GPU, that they require at least 128 gigs of memory. And so this can now also take the role of like a baseline that a tool requires. And then 3.1 also fixed some of the bugs around inheritance, because you can inherit rules, like you can make them ever more specific once you start subclassing them. And then 3.2 focused on making things more explainable. So these scheduling decisions can become very complex, and to know why a job was routed to a specific cluster was a little tricky. So now there's the --explain command that routes, that shows the decision tree. There's a merged config dump. Again, if you have things distributed over multiple files, it's maybe a little difficult to understand what you actually have there. And you can also address tools by the tool type. And again, the driving use case there was custom tools that have like separate security policies attached to them, because you wouldn't want to run them on your local cluster with access to the data as other tools might have. But it also applies to interactive tools that you can also address in this way. So the stronger configuration validation was already mentioned. So for each thing that you type or that you add to your TPV config, we can generate temporary Python code that has the actual type annotations, because we know that like the default mem field of a tool needs to be either integer, float, string, or none. So yeah, if you return a set here, I think this is supposed to be a set, I mean, it would fail validation. I'm sorry, I mean, I'm not doing justice here. Okay, so yeah, it's trying to build like an F string here in something not defined. That's not good. The same here, mem2 is not defined, right? And there's the thing I spotted, that set. I mean, this is not the right thing to return here. It should have been one of those data types. Yeah, I mentioned that you can now compose layered configurations. So it's very important for like the community file, because the community file, like people may change it under you, but you can like set specific overrides for specific tools that match your infrastructure. And then TPV dump still outputs that final configuration and omits the things that are not applicable because you've overridden it with your site-specific defaults. Yeah, you can define cores and memory directly in tools, so that works. We've added it for user-defined tools, but you can do the same thing for XML. If you as a tool author already know you need a GPU or you need at least this much RAM, you can specify that. Yeah, and then inside the scheduling tags, you can, no, these are not scheduling tags. Inside the destinations, you can accept or reject specific tool types. And it's all typed because, yes, typing is good. Yeah. Yeah, you got the explain flag. So here it's basically asking what were the scheduling decisions taken for the anti-smash tool. And then the entity, you can see I'm not an admin. All right, let's say this is very important. Yeah, I mean, I do understand the value of the shared database. That is quite, I mean, I understand the importance when you're trying to debug this. However, I don't like fully understand what oh, I see. So it's like, these are the things that are required by the tool, and you don't want to go to offline destinations. And then you do want to prefer Pulsar. So what works is Slurm, because Pulsar is only preferred. Pulsar works, the others don't have enough cores, or Slurm training requires a training tag that the tool entity doesn't have. So these are the available destinations, and then they are ranked, I guess, by the, I would imagine that the Pulsar destination is the right one. No, Slurm. I don't know why Slurm is preferred. Okay, whatever. Yeah, for questions, you can ask the admins or a new one. I mentioned the shared database, so that's really nice. You can pin them by major version, so that like as you update your job configuration, it doesn't like change how you run it. It's sometimes we have updated when like there's new features available in TPV, but so far that's not been necessary. However, you can also go directly to the latest if you, for instance, want to use this with a real cluster, but you're just doing an ephemeral Planemo instance. That's very useful that you can just say, give me the latest rules and resource allocation I will figure out. I'll do. Yeah, so where does that leave v3 pulse of TPV? Yeah, it's a flexible scheduler, and on top of that, you can validate, explain, and operate any sort of cluster and multi-cluster environment that you have. It should be robust, introspectable, and admin-friendly. Yeah, thank you so much. Thank you to Nuan for the slides. Yeah.
Thank you. Could it be possible to provide for the kind of old-fashioned way to use a computer like SSH an access to the TPV? So we can maybe give the tools, maybe the size of the data set on people. We get advice. Okay, maybe you can book 1 GB of RAM or instead of 100 GB of RAM, etc. So maybe provide this outside Galaxy. For Slurm users.
Oh, you mean like for a command line user that submitted a job?
Yes.
Yeah, I think there is plans to extend TPV to make it a more generic infrastructure also for other systems. Yeah.
What does it mean to right size a GPU in this context? Like, are you restricting the amount of like memory or just?
Yeah, you can, right? So you can allocate like half GPUs, 1.5, 2, and like there's often like an asymptote, like you reach like the maximum, like once you throw 20 GPUs at the data set of a given size, it may not increase past 2 or 3. That's generally true for also the CPU and RAM. It never hurts to put more in the sense that the program's not going to slow down, most likely, for things that are well written. But yeah, I mean, it's just efficient to not over allocate and leave enough space for other people on the cluster, other Galaxy users. That's the idea with right sizing.
Thanks. So we have Anis and Isis Narves Bandera. I'm not sure which one of you starting.
I'll start. Well, yeah. All righty. Good afternoon. So I'm going to present this or co-present this with Isis. I'm in Mike Schatz's lab at Johns Hopkins. And so the way we'll do this, I'll talk about the sort of infrastructure underlayer of running Galaxy in a environment that's suitable for working with protected human genomic data sets. And then Isis.
Hello, I'm Isis. I'm from Gex Labs. Actually, I'm going to present about workflows in build data in build for Galaxy Enable. Then let's start.
All right, so so Anvil is in its year 9, I believe. It's a US-wide project funded by a branch of the NIH that set out to combine all these massive data sets of otherwise sort of protected data that you have to get approval to access and work on. But also, more increasingly, you have to make sure that the environment in which you analyze it is also sufficiently protected so that data doesn't leak or fall in the wrong, where it shouldn't, the people that don't have access to it. And so that was one sort of element of Anvil, collect all this data that's provided by this NIH Institute. Then, of course, if you have data but no way to analyze it, what good is that? Hence came the idea of combining it with apps. And so in this case, we think in Galaxy in terms of tools. If you think a little bit more meta, you start talking about apps. So Galaxy being one such application, and Terra being another one from the Broad Institute, like Bioconductor as in our studio being another module. And so there's a number of these apps that have been integrated into the Anvil workspace. But then again, to kind of go full circle, you also need infrastructure to run all this on. And so this is deployed on the Google Cloud. So you essentially have this fully self-contained system data applications and compute that runs in a secure environment so that you are able to analyze protected data. And so the goal here is to sort of talk how Galaxy operates in this environment, but also show how it's useful by applying some of these data sets through the Galaxy interface to get useful results. And so unlike, I'd say just about every other Galaxy that I'm aware of, certainly, where it's a multi-user system, people can access it, work with it, and all. You install one Galaxy, many users. In Anvil, because of this sort of protected environment, we have to install Galaxy so that one user gets one Galaxy. And so there's a lot of this collaboration and sharing and all kind of goes out the window. But it also complicates the process through which you launch Galaxy, because it's essentially a semi-autonomous system. We can't and don't make every user an admin. And so you kind of have to have a reliable system. And so, as I said, this is year 9 of the project. We initially started off doing this using the Kubernetes and the Google Kubernetes engine as a platform through which we run Galaxy. But it had one particular issue, and Isis will kind of highlight this, is that you have to know what workload you're going to run on it, whether you need to launch a small cluster or a larger cluster. And depending on that decision, your costs were proportional. But as a user, you often don't know this. And so as sort of user is growing and Anvil is getting more adopted, we realized, well, we got to rethink how we deploy Galaxy on Anvil, and we set out these 3 goals. So we want to lower the cost of infrastructure for users. We want that quicker application startup. We're all used to from TikTok to use Galaxy.star, like pulls up in seconds. Waiting 15 minutes is not really desirable. And then we, as now maintainers for many years of this, we realized just how difficult it is to maintain a system that the way it was initially deployed. And so we did a couple of things here to over the past year to kind of help this out. One is we, instead of using Google Kubernetes service, we swapped it for the Google Batch service, which means it's a dynamically scalable infrastructure that if you ask it for 1 CPU, it'll give you a virtual machine with 1 CPU. If you ask it for a machine with 20, you'll get 20 for the duration of that job. And meanwhile, you still have to have somewhere to run Galaxy. So we have a small VM that run Galaxy. And so we accomplished 2 things by doing this. One is our sort of startup time roughly halved. Still not great. I'd like to get this down to like under a minute, but we'll see if that's technically possible. But 7-8 minutes is certainly better than 15. And then our baseline cost, meaning that when you launch that instance and you just let it run, whether you use it or not, has gone from at least 50 cents an hour to now 22 cents. And depending on the size of the cluster you launch, that can go into multi-dollar scale. So I think, again, an accomplishment. And so, but what I think with this kind of, it's kind of like the stock market, like it's the long-term compounding that actually adds up. But if you launch an instance and let it sit idle because you need to come back to this tomorrow, you're waiting on your collaborator to look at something, that idle cost is now much, much lower than it was before. And it's at no point higher than it was before for the same capacity that the given cluster was able to process in a given timeline. So I think that too is a win. And then lastly, for me personally, my favorite element of this is that we now no longer have to go through this 3-group coordination, a month or 2 long process, because there's something in Galaxy that was maybe either a bug, which hardly ever happens, or like a new feature that we want to roll out. And so now we have this independent rollout process where we just the Leo and the Leonardo and the Terra side just point at our branch. When we update the branch, we automatically roll out a new version of Galaxy, and it's in our control. And so in a really fast 5-minute window, that's the new infrastructure behind Anvil. Not quite available yet because we're going through that 3-month process of coordinating with Leo, but in the next month or so, it will be. And with that, I'll hand it over to Isis to talk how she's using this now.
Okay, thank you. Thank you, Anis. Okay, then after establishing the Galaxy on Anvil infrastructure, our goal was to evaluate whether Galaxy best practice workflow can be effectively deployed and used on Anvil. The biological question that we asked was simple. Can gene expression tell us how old person is? Galaxy on Anvil offers several advantages for this type of analysis: secure access to controlled data sets, reusable workflow from the Galaxy community, scalable clouds, computing, and fueling reproducible analysis. For our analysis, we use GTS data. We analyze 21 different human tissues. For each tissue, we compare two groups, the young donors, people in their 20s, 30s, and 40s, versus old donors, people in their 60s and 70s. We exclude the 50 to 59 age group because it's a transitional decade. We had around 2 samples per tissue, and we test more than 50 genes. And here is something very important. The data never left Anvil, no downloading and no moving files. All was running into Anvil. Then before showing the analysis, let me quickly explain these workflows because it's how we run the analysis. We start here in the data in the top in Anvil Data Explorer. This is where you search the data and then you look for the data sets. Then the data is exported to Terra workspace, the secure environment where manage all the project and our data access. From Terra workspace, we launch Galaxy, where all the analysis happens, and Galaxy connect to the toolshed which provides the analysis tool and Galaxy. And the Galaxy IWC, the Intergalactic Workflow Commission, library ready to use community review with workflow. So in practice, we find the data, we open a workflow in Anvil, and then we launch Galaxy and run all reproducible workflows. And let me show you how I did it. This is the pipeline we built in Galaxy. After set up the data sets for each of the 21 tissues, we run 3 workflows. The first one was differential expression with the SIG2. This tells us which genes are significantly different between young and old persons. Second, enrichment analysis, we go SEC and we KEC. This tells us which biological pathways genes belong to. And third, machine learning with tabular learner. This tool automatically compares different classification algorithms and picks the best one to predict whether a person comes from a young and older person. Now let me show you how this looks like as a scale. Across the 21 tissue, we run 63 Galaxy workflows. The differential expression step perform more than 1.18 million of statistical tests. The machine learning steps automatically compares more than 300 models with no manual tuning. In total, more than 4 times samples processes, over 11,000 differential expressed genes found, and almost 2,500 enriched pathways identified. And the compute timeline, the full pipeline for one tissue take about 1 hour and 35 minutes. For all the 21 tissues are roughly 33 hours. Every step tracked in Galaxy history. So the next question is, whether these workflows produce meaningful biological results, and the answer is yes. Each leaf a transcriptomic signature in every tissue we studied. Every single one of the 21 tissue shows significant age-associated genes. And now look this, the second chart, the machine learning results. The mean AUC across all 21 tissue was 0.8, and 20 out of the 21 tissue are about 20, which is typically considered a good classifier. The best one, nerve, and even with the lowest, that is skin, is about the chance. But one of the most important and exciting finding is this: the gene CAYP1 was detected by our machine learning model in 4 tissues and appeared as significantly differentially expressed gene in 5 tissues, with heart, lung, and stomach showing both signals simultaneously. 2 completely different methods pointing the same gene. This is biological validation from both sides, and this is not random. CIP1A1 is regulated by the ARCH pathway, which is directly linked to oxidative stress and cellular senescence, 2 hallmarks of aging. Then to close, three takeaways. 1, the new Galaxy on Anvil deployment scales with your analysis cost, state proportional to the workload, no waste computed, no idle time. That is what made running the 63 workflows across 21 tissues practical. 2, Galaxy on Anvil enables working with protected data without data sets like GTS already preloaded, no downloads, no compliance rates. Your data is stays secure all the time. And 3, use Galaxy IWC workflows to really analyze the data. Everything we showed today is built in community review with reproducible workflows that you can run right now. Confine us to the poster 8 today and to the poster 20 tomorrow. This is the acknowledgement, and thank you.
Thank you for a talk to both of you. In terms of the reduction of the costs and the startup time, what type of technical solutions enable that?
I mean, a couple of things. One is, so we pre-build the machine image to have it preloaded with all the libraries and all, so that sort of eliminates some of the startup time. Secondly, I mean, and really that's the bulk of it, is the elimination of the use of the Google Kubernetes engine, which is just slow to start. And so that part, it just, we opted for like what I consider like a 15-year-old solution, but a better one, because that VM just starts in 10 seconds. And then, yeah, I mean, there's some work from, I think, Marius that, because now most of the time is spent in loading the toolbox on Galaxy. So if we can reduce the startup time for Galaxy itself, I mean, that goes anywhere from like, 2 minutes to 7 minutes, depending on something. If we can eliminate that, we can be up in a minute or 2.
Thank you.
There's one more question.
Thank you. When you say about the toolbox, do you load all the tools, or how do you basically select it? Like, do you go per community or per request from the users that are coming for you?
Yeah. So we have so it's in it's on GitHub. It's a repository that sort of manages what gets installed on the CVMFS. And so that currently consists of everything, all the work tools that are in all of the IWC workflows. And then on a per request basis. So basically, if anything that's being used in in IWC, what we still want to add is everything that's in training, all the tools that are used in all the workflows across the training. But it's not a super there's not a request form.
Can I do a follow-up question? Isn't it better in this case to actually make it requestable per users, depending basically on their workflow that they want to bring? Because I think that's will, first of all, spin up your analysis, like not analysis, but the runtime to deploy the Galaxy, but also will drop like the cost.
Yeah, so we added something, again, in this new version not rolled out yet, is you can pre-configure what workflows and data get preloaded as Galaxy starts. And that's in a YAML file. And so when that happens, yeah, an easy extension would be to make sure those the tools in those workflows are installed. All we have used thus far in testing is IWC workflows. And so we didn't actually exercise that stretch that you just brought up. So yeah, good.
Thanks.
No, nope.
Let us thank again Luis Sanamis.
Thank you very much. So thank you, the colleagues, to accept at the last minute to come and speak. So an update on Galaxy ecology, something I want to introduce quite briefly. is the fact that sorry for my bad English, first of all. It's the fact that when we are looking at something, it's really hard to see if we need to be part of it or not. And for me, it appears now that, in fact, the origins of the things can help us to know if we want to go in this, for example, community of this work or not. So I will briefly speak a little bit about the birth of Galaxy Ecology. It was born, in fact, in a citizen science project where we wanted to test help facing the issue regarding the data NAMI, looking at involving citizens in data analysis in biodiversity. So that's where we were proposing to use existing platform who can gather something like unlimited number of users around data and tools. And it was followed by first Galaxy Ecology instance production in Europe, thanks to usegalaxy.eu. And then it was something who was used in a national project devoted to create research infrastructure in France related to data, biodiversity data analysis and management, who is called PNDB. And then these PNDB biodiversity things became, in fact, a hub of biggest infrastructure, research infrastructure in France, who is called DataTerra. If you don't know what is DataTerra, please come back to see us on the booth, something like that, of DataTerra at the conference site. So with Galaxy Ecology, we were working since 9 years now, something like that. And we just published our first paper last year with Colin Royot, who was a PhD student working with me, where all the major feedback from all these Galaxy Ecology things was in fact contained in this abstract, who is just describing how we can take a script from research in ecology or in biodiversity, like a R script, and go towards what we call the natomization generalization framework to have pieces of code we can share with open source licenses, and we can combine in workflows thanks to workflow managers and web platform, like, for example, Galaxy. One of the major part of this was to see the benefit we can have to structure a community around sharing and peer reviewing the source code we are producing to analyze and manage biodiversity data, and notably in one particular goal with the production of biodiversity indicators. So if I take this kind of big shape, yeah, but looking more at the variables, at the data, it's exactly the same that trying to use the same workflows, the same computational workflows, but on heterogeneous data. And in fact, this is something we can do if we are thinking about the fact that even if the data, the input data sets are heterogeneous, they are sharing the same concept on the primary variables who are in it. So this is something we can have here, for example, who can allow us to have the same workflow to produce the same biodiversity indicators on abundances of species, for example, for birds, for fishes, or for butterfly, dealing with the heterogeneity of the raw data set we are using as input of such a workflow. And what is the benefit of that? Is that you can transpose from one species to another, but you can also transpose your workflows to one area to another. So for example, here we just show what we can do with an eco-regionalization workflow who are developed to be applied in Antarctica conservation particular issues, and on Atlantic data and other kind of data, for example, fishes or marine invertebrates. One of the really interesting things we can see is that when we have a workflow who can allow us to do this kind of things, we can also define some parameters. For example, here it's environmental parameters we can feed to a model to create this species model, species distribution model. And we can easily play with the parameter we are taking into account to just look at the different occurrences of the models, but also to allow experts to look at the results really rapidly and without pain, just because they can have access and they can reuse the same kind of workflows. So if you want to know more about Galaxy ecology, we have a lot of tutorials, something like 30 now, because we really are trying to, each time we develop something, to create a dedicated tutorial. And now I will just focus on some specific aspect we are working on with my colleagues. So there is Pauline there, who is working on Gaia data. And this is one project you will also heard about with Galaxy Earth System Science with Marie just after. The idea of the project with Pauline is notably to support and to help the creation of this Galaxy ecosystem around Earth System Science, and notably helping the production of several tools for modeling, for data access and management, notably in earth science, and for management and analysis of media like sounds, images, videos, and working on interoperability between data lab solutions, so other solutions than Galaxy. And there is work, we are working together, notably with Marie and other colleagues. There is Jérôme, there is a lot of colleagues there from BRGM too, from INRAE, who are working around these Galaxy Earth system things. And we are working also to ameliorate the training, to create ameliorated training, make support, and develop the European remote computing pulsar nodes development. After that, I will let Arthur and then the other colleagues present their own things.
Hello, everyone. Sorry for my bad English. Quickly, we use video, GoPro video with tool with filmed in Tidypool. And for annotate and segmentation this video, we use last model by Meta is SAM3. The first version of this tool can add take a prompt for detect and segment object. On input, you have a Coco JSON, and with this JSON, we can edit and remove, keep, or rename the annotation, because SAM3 is very cool for segmentation, but the label is not very specified. And for the citoyen science of Morev, we need to have a model very specific of species.
Good afternoon, everyone. My work is more focused on spatial planning, so I think I don't know if you've seen, based on this, can I see my pointer? Yeah. So yeah, based on this graphical abstract here, really pretty, right? I'm trying to reproduce actually the same work, but instead of going from a classical anatomized script, I'm going right, I'm working right from a, from an article data. I'm working actually on an article from 2014. The challenge with this article is that it's using methods and data that are pretty old right now. I would say or something like from 20 to at most 30 years old. And as of now, it's well, it's pretty hard to reproduce the analysis due to the fact that not only the data can be hard to access nowadays, but the we only have the results in the article, but not any script with the containing the analysis that has been performed. So my work here is to going from this article. I will first identify the analysis that has been conducted here, and then with Galaxy tools, I will reproduce them so that they can be reproducible. Sorry, but they could also be applied in other contexts other than, here it's a work in East Antarctica, but hopefully we could use it in other contexts, for example, other marine coasts. So yeah.
During my internship, I'm developing methods to facilitate the development of Galaxy tools based on the existing codes. The first method helps convert tools made for the box pipeline engine into Galaxy tools. So it creates a wrapper, an XML wrapper based on another wrapper format. It also adapts the scripts to work in Galaxy. And the other project I'm working on is the improvements of the package NB2 Galaxy that converts Jupyter Notebook into Galaxy tools. For now, it only works with notebooks written in Python, and I will adapt it to add our language compatibility.
I will talk shortly about my work, but my poster is tomorrow, so it's poster 16 if you want to ask some question. My job is to first updated OB tools, like the previous version on Galaxy. So it's like tools from to process metabarcoding datasets. And after, I added some tools to manage taxonomic database, PCR, to do some PCR in silico, and that's it. And after, I work on the use case to make workflow, a multi-marker workflow with an Antarctica dataset.
So thank you for your attention, and don't hesitate if you have questions, comments, and just a picture to thank all the collaborators, and notably the chance I have to work with a lot of young, motivated people with me.
Very nice presentation. I really enjoyed it. So I saw that you were doing this on the Use Galaxy U subdomain. So what is your project process to get the tools that you've developed back up to Use Galaxy U?
To add tools in Galaxy U? Yeah, for now we have we use the Galaxy Europe process to propose to have new tools, for example, using YAML file where we just list the tools we need once they are in the toolshed. We already have the CI/CD who are uploading the tools on the toolshed thanks to the ecology communities. And after that, there is also some manual things we can add. I mean, for example, for people who want to add some tools on Galaxy Europe, notably if you will need to integrate some tool section on Galaxy Europe. And maybe this will change a little bit with the questions we have and comments around the organization of tools, section of tools, and things like that due to the things presented this morning.
Thank you. Next presentation will be from Galaxy for Earth System Science from Marie and his group. Okay.
Hi again, everyone. So I have with me Mathieu and Jérôme that will be also presenting during this talk. And so I'm Mary, and I will try to introduce to you Galaxy for Earth System Sciences. So we call it GESS to shorten it a bit. So the title here is Advancing Earth System Research through Galaxy, Dataterra, and EOS Collaboration. So there are a lot of words, so I will try to explain them during the talk. Hopefully you will understand, but it's a bit a huge mess. So we'll see. So a bit of history about GES. So 3 years ago, the Earth System community took its first steps in Galaxy with a project named Ferries. And today it's a growing ecosystem connecting French and European researchers through open reproducible science. So GES was born from the project Ferries and is now sustained and supported by the research infrastructure Dataterra, both at the French and the European level. And so for the European level, it's also thanks to EOS collaborations. A bit about what is EOSC. So the EOSC is a key initiative that by the European Commission to provide researchers with open, seamless access to data, knowledge, services, and infrastructure for open science. So it has first three main goals. It's to have a portal where European researchers can access scientific data, services, and tools for analysis. It also has a second goal on community for sharing data, services, and expertise across all scientific fields. And finally, it aims to have partnerships governed by the EU member states and the EOSC Association representing users and providers. So in this big framework of the EOSC, where you have multiple partners from different European countries, they decided to create what we call EOSC nodes. So it's research infrastructure or group of research infrastructure trying to bring their expertise within the Europe and have a standardized and global access to research data. So in this environment, we have Dataterra, which is a EOSC node also for environment. So Dataterra is first a French Earth observation research infrastructure. It aims to provide scientific data, services, and infrastructure across Earth system scientific domains. So the Earth systems is a complex ecosystem with dynamics between atmosphere, hydrosphere, geosphere, and biosphere. So to represent these different dynamics, the research infrastructure unites 5 disciplinary poles, which are called Audatis. So we'll have a more focused presentation from Jérôme afterwards on Audatis. We also have ARIS for the atmosphere, which is really linked to the climate part. So we also have a collaboration ongoing with the climate people to see how we can work all together on Galaxy. And that's actually one of the questions of above that we have later on, because we are overlapping with the climate community. So we want to see how we can co-construct our community and maybe start something where you do not have overlapping communities at first. Then we have the PNDB. So it's actually what Ivan just introduced you. It's the community on biodiversity and ecology, which also have its own instance on Galaxy. We have Theia with continental services. I will show a bit of a use case on this part also afterwards. And finally, we have Formater with Solid Earth. So we have some representatives also of this part with Vlad Bizan, who's somewhere in the room over there. So if you have any question on Solid Earth, please go see him. So Dataterra is included in multiple projects, but I will talk about 2 main ones. So the EOS node that I presented to you, which is how Dataterra can provide a single sign-on onto high-quality, trusted, fair, AI-ready multidisciplinary data for the Earth system. And it also has another project, which is Gaia Data. So Gaia Data is the French part. It's a project that is led by Dataterra, Clermont-Ferrand, France, and PNDB to facilitate access to data from observation modeling and understanding of the Earth system, biodiversity, and the environment. So as you can see, this project, even if they are French from a side and European from another side, they're quite overlapping. So we are trying to work in a harmonized and logical way on this different project with Dataterra, both at a French and an European level. So More specifically, what is the GES service? So as I told you just before, GES is actually maintained and sustained now by DataTerra. So it's Galaxy for Earth System Sciences. So we're trying to have a complete service, not just based on one instance or one lab on a Galaxy instance, but also to have tools and workflow to try to bring our resources like distributed computing we actually have right now two Pulsar nodes, so one in Greece and one here, actually, with the UCA. This one was also put in place during our project ferries. And we hope to bring more resources and more compute resources with the different hub of DataTerra later on. We are trying also to have a community building. So as I was telling this morning, we are quite new. We created this community about 3 years ago, and it's growing. But as Galaxy was first created for bioinformatics, it keeps on getting hard to get people to think that Galaxy is not only for bioinformatics, that is actually domain agnostic, and we can also use it for other domains. So that's a huge part of our work to build the community. So if you are interested, please join. You can have here the channel matrix room with the QR code. And also, of course, we're trying to support and provide trainings on our different Earth system topics. So we're really invested on this part also and trying to bring as much help as we can to bring the Earth system sciences within the Galaxy ecosystem. So as a service right now, GES has one subdomain on Galaxy Europe, which you can find at earth-system.usegalaxy.eu, but it also has a lab on Galaxy France. We wanted to test-proof the lab deployment and help the lab community construction to see how easily it was to be deployed. So we did it quite easily on Galaxy France, and now we have also our specific instance on Galaxy France. We have our Earth data AAI, so DataTerra's one, which is available on Galaxy France also. And all of this work is going through a collaboration with IFB and the people from Galaxy France. And we also hope to bring later on more resources with Pulsavia on this instance, but also on Galaxy Europe, where we still have the original GES, which is the subdomains have multiple interactive tools, the login, which is in accordance with the EOSC 1, and we want to foster also the European collaboration through this instance. So here, this was about DataTerra and the GES service. So now we're going to focus a bit about one of the disciplinary poles. So I will let Jérôme speak about Audatis.
Thank you, Marie. Hi, everybody. So I'm Jérôme Detoc from DataTerra, and more especially from the French Marine Data and Services Hub. And I'm a lucky guy, and I'm not a lucky guy just because I work with Marie during the EOS Ferries project, but I work in a project that the principle is to make some cross-domain data analysis on Earth system with Galaxy. So it was quite a success, and now Galaxy for Earth System Sciences, GES, is a sustainable services thanks to DataTerra. So for my part, I have to now I'm come back to marine science and to help scientists of this field. And the marine science community or people that know how to develop. So for us, we want to place Galaxy after the development phase, after Jupyter Notebook, after Jupyter Hub, we already provide R and Python environment connecting to HPC facilities. But what we don't have is training and reproducibility solution. It's very painful now to reproduce an analysis, and that we want to try with analysis. So we will do the same as we do during ferries.
we communicate, we engage the community. It was quite easy for us because we are placed on institute near the lab. We have to provide an operational platform based on Galaxy for system science hosted in Galaxy Europe, but we have to connect our HPC, our data set, our reference data. And after, the third action is to support our team that want to bring their tool that are convinced by the first and the two first actions. Thank you.
Okay, so I will quickly introduce a work from our colleagues from NFDI for Earth, a German research infrastructure with its community 3D-trees.earth, which is a website. So I invite you to go through it. So here you have their Fairpoint Cloud analysis, which is a use case from 3D.earth. It focuses on the analysis of forest point clouds, which are 3D data sets created from laser scans of forest. On the left, you can see that the key idea of these scans is to capture forest in incredible details. So with that, you can have the raw data, which is large and complex. So researcher needs tools to process it and run it to a useful information. So 3D-trees.earth bring this kind of forest data together with analysis method using Galaxy as the workflow platform. So here's the workflow that is behind it. You can directly find it on Galaxy, and afterwards, you can test everything on the 3D-trees.earth platform. It's pretty public, so feel free to test it, and we will try to create a tutorial during the summer so that you can directly see it. Sorry, I have to go fast. Also, I wanted to present to you the EOSC Aqua Infra, which is based on fresh marine waters and has its own Galaxy instance, which is aqua.usegalaxy.eu. So it has the same objective that Dataterra, but based on freshwater. It has multiple use cases across Europe. And one of the use cases they worked on within Galaxy is the Daugava use case to do the optical properties in the Gulf of Riga water change in the long term. So please go through the slides if you want to know more. And from the the European collaboration, we finish with the French collaboration.
Okay, so I'm going to tell you a little bit about the French project I'm working on currently, which is called À la Mode. So to sum up, it's basically a project that aims to gather and complete data on carbon stock exchanges in biomass and soil across a network of sites in France. And so the goal will be to develop models to complete these data sets and to compare these different models. So what I'm doing on this project is that I'm developing tools for this community in order to allow a wide community to produce the inputs for these models that will predict the carbon stock exchanges. So I will be deploying tools on the Galaxy ecology instance. The two of them will be about the extraction of climate data directly from. So this is like this tool is actually uses a French API to get French climate data. But I will be also deploying a tool that will allow user to extract ERA 5 data, so directly from the Copernicus with the Copernicus API to extract climate data on a European scale directly into the Galaxy interface. I will also be deploying another tool, which will be a bit smaller. It will be an ePSG conversion tool, so coordinate system, coordinate reference system conversion tool, so that you can move from, for example, the GCC2026 main one to any other ones. And that may be like very useful, like as a first step to for different workflows that use coordinates in any kind of way, whether it's latitude, longitude, longitude stuff, or more like polygons, line, and any other way to show and transform coordinates.
Thank you. And you may have questions, but we also have questions for you. So please join our booths.
You mentioned that very nice presentations, like really cool. You mentioned that like you had some trouble reaching users because they thought Galaxy was for biology and life science. Like, can you say a few things about this?
Yeah, I think the most frequent answer I get from when I try to tell them to use Galaxy is that, yeah, but we're using really huge data, and so Galaxy cannot process this kind of data because it's really huge and it will take too much time or not run at all. And that's the kind of things I'm stumbling on because I actually don't have the experience on that, so I don't know how to answer.
How huge is huge? Because biology data can be extremely large.
Yeah, it's satellites data mainly. Okay. So really huge.
So are we talking petabytes or?
Yeah, I think so.
Great, thanks in the interest of time. So let's thanks Marie again. Okay, so next the presentation will be all about natural language processing in Galaxy with Daniela, please.
Thank you very much, everyone. Guy Suderman, my co-presenter, rightfully said, we lost our opportunity to name this talk and now to something completely different. So we should have done that instead, maybe. But we're actually quite neatly meeting the question that you're also asking: how do we get different user communities to use Galaxy? And my approach right now is trying to use tools that are well established within the community and set them into the system to show that workflows and the reproducibility can make a benefit. If this is working out, maybe we can talk about this next year or in 2 years, but this is the approach that we took, and this is also why we are using this very warm timing to give you an idea of what we are doing as a special interest group and also what tools we're actually using. So quite generally, I'd like to give you an idea of what user group are we actually talking about, and then show you some specific tools and how they can maybe challenge some of the problems people might have when they are trying to use a computer on historically analog data. So this is a non-exhaustive word cloud that shows the diverse fields that arts, humanities, and social sciences can encompass. This can be from archaeology to political sciences, but also you can talk about people how to analyze social media posts, and on the other hand, then go to art history. So this is really a diverse field, and I'm not going to say I'm an expert in all of those. So there's a huge gap also. And people from these fields can look at the same thing, for example, one book, and have completely different approaches in their best practices and also in the ways that they are approaching that. And we are, of course, trying to help them to do that in Galaxy. And one essential thing is they already have a very long history, because many of those fields are actually among the first university fields that have ever been created. So, for example, theology and languages are among the 4 pillars of European universities. Should you ever want to know more, I'm not going to bother you with this. But because of this analog history, it can be quite challenging to now convince those people who have for like 800 years relied on using their methodologies, maybe printed books, for example, to now use a computer. It's not always an easy challenge. And so these non-born digital challenges can be that, for example, you have a lot of sources, but many of them are machine readable. So what do you do with that? Quite often people say, yeah, Galaxy is nice, but how do I use that with my old manuscripts from the medieval times? Good question. Another thing is that they quite often don't have the resources to use computational methods. So getting to know Galaxy is already a great step if they get that far, because also programming skills are not part of the standard curriculum, and actionable workflows I don't even want to get into. So that can be very, very overwhelming for individual researchers. And this is where I hope Galaxy can help. As all of you know, there's many different tools, and we are also continuously improving on the tools that there are for the humanities and social science crowd. Because also there, when it's not something you need to install on your own computer, that is also already breaking down one important barrier, because when I worked in that field, I wasn't allowed to install anything on my computer. Also, breaking down that you don't need to use any programming languages, and the command line interface are helpful. And also, if you're having reproducible workflows, that means somebody who's really an expert in this field can create something that you, somebody who may not have that expertise, can use in a way that will still give you good results, and you don't have to get that deep into things. I also hope that this is something that can lower the introductory barrier. And of course, the Galaxy training network that I think always deserves more praise, where we are trying to also build more tutorials to guide people step by step into how to make their analyses. And another factor, of course, is community. It can be really alienating to be on your own and trying to go on this endeavor. And this is also where we would like to help. And I already shared this QR code earlier this morning. If you are from this field or this speaks to you, please join our matrix group. And also there will be a birds of feather meeting at 5 today, so directly after this talk panel in the cafeteria. So we will also try to get together synergies and continue working on this. One of the areas that that Galaxy currently doesn't cover is natural language processing. What is that? Natural language processing includes a multitude of methods and techniques which circle around the task of understanding and generating human understandable text with digital machines. That's one way of putting it. And maybe this is something you think, yeah, that's far away from what I'm doing. Well, actually, a lot of the internet is already building on this. So text preprocessing, for example, helps you to break down complete text into different parts. For example, figuring out what one word is. And I know in English, it's easy. You take the space before and afterward, it's done. I did my PhD on Chinese newspapers. I can tell you the challenge I had to find what one word was. Completely different topic. You can do part of speech and dependency parsing, which is a technique to use also to understand the syntax and the structure between different parts in the text. But this is a task that linguists will be able to tell you much more about than I am. Another thing is sentiment analysis. So this is also something you will be familiar with. You can look at all the reviews your tutorial have ever gotten and give them to sentiment analysis and see, oh, 95% good, I did a good job. Or this is the challenge that I need to still work on. One of the things that are most valuable for me personally is named entity recognition. This is an option for you to extract information on a large corpus. So for example, you can extract names and regions by just passing this through. And this is giving people who are normally used to reading page by page a real great insight, because you can test hypotheses at a very quick glance. And on Keith's initiative, we are now bringing NLP to Galaxy. So we are in the process of adding 6 tools. 3 of them are already added with the help of the review from the European Galaxy team. So thanks a lot to Simon, to Rand, and to Björn, who already helped and are still helping in making this possible. So we have Stanford Core, Spacey, Stanford Stanza, which maybe some of you have already heard of. So these are very well-known tools already. Then we have also core occurrence analysis, geo-entity coding, and Vader sentiment. So giving you a wide range of different languages that are supported within those models, and also that are covering many different NLP tasks. The advantage of using those in Galaxy is, of course, you don't need to know any programming. And also you can very quickly check between different programs without having to set them up first. Quite often it's like you need to set everything up. It's challenging, but you just want to know if it's actually working on your data. And this is something that I think Galaxy can bring to people that's very user-friendly. And also, since a lot of the computational support is limited to English, these multilingual tools are a huge resource for us to also not leave behind all of those fields who don't primarily work with English. And also with the Galaxy environment, there is the reproducibility aspect that we have. You can connect it to other tools. For example, I mentioned, what do I do if my book is not scanned yet? You can use optical character recognition in Galaxy, run your whole text through text recognition, and then you can work with the text that you have and then extract entities or however you choose. So now we're getting to the favorite part where we are leaving the theory behind and we're going into practice. So not everybody of you will know German, but I browsed through the University Library of Freiburg and I found this wonderful scan. It's from the 1920s course catalog. And I mean, back then people didn't know GDPR, so they published a list of lecturers' flats with addresses. And I thought, oh, this is cool. So where did these people live back then? So I had to break down the document. So basically, every tab says the name of the lecturer, then their position, there's a flat address, and for some there is a phone number. And you will notice it doesn't contain the city that they lived in most of the time, or at least not for Freiburg. So the first step that I took at that time, the scan again was not machine readable, so quite useless to many people if they don't have access to using those specific tools. In Galaxy, we have multiple options of doing that. In that case, I used our LLM hub and created a markdown file that you can see here. I added a bit of cleaning. I extracted only the addresses, as you can see, because the people's names were less interesting for that question for me. And very importantly, I added the city information in another column. And then I ran, in that case, the Spacey NLP for named entity recognition. And here again, you see you can choose different models. You can also decide what output to use, and you can also select your language. Again, this is on German, so this is not something that every model will smoothly work with. I get this JSON output. That's not for me, but that's for the next tool that we are using. And this is the geocoder. And the amazing thing about that is that I can give it a location and it will find the latitude and longitude for me. So I can actually map it. And I can tell you, I've been trying to do this during my PhD just to prove a hypothesis with Python. It never worked. And I'm so excited that I'm able to present this to you today because that would have helped me quite a lot back then. So you see, now I get like the street name and the city name and latitude and longitude information that allows me to map this. So if any of you know some historical work, you'll say, this is a modern map, this is not okay. And I agree, this is not okay, but this is a proof of concept. You could quite like this, use the entity information and map it in QGIS on your own historical map, maybe for next time. And also it's very interesting for me to see with a quick glance, I could just switch the model and then I could see that the, for example, Stanza completely messed up the city names. So in that case, even though it had the information, it should be in Freiburg, it located it in Munich, Berlin, or Zurich instead. And getting a quick comparison of those models is super valuable to me. So, and this is how we get from image to insights. And a big thanks to Keith for bringing this up, for the European Galaxy team to support this, and particularly to Rand, to Syme, and to Björn. And of course, to all our supporters who made this possible in the first place, and the amazing Galaxy community that I'm building with all of my work on. So thank you all very, very much.
First of all, I want to compliment you on the fabulously cool example with the addresses. This is awesome. This is what digital humanities should be about. Thank you. Of course. I was just curious. So the presentation mentioned Stanford Core NLP, and I was wondering if there are any other popular sets of tooling you had in mind, which you thought that in the future down the road it would make sense to wrap, like maybe an LTK, and I don't know whether or not it's still used in the community. I'm just familiar with it from the faraway past. So besides Stanford Core NLP, anything else you would suggest wrapping?
The more the merrier, right? So we are like together with Keys, we decided on 6 tools for now as a proof of concept and see how the community is approaching it. If we have capacity for NLTK, works fine with me. I'm personally more familiar with Spacey, so we are also adding this, but we are open to that. It's just about that people are actually using the tools, and that I'm not making a lot of work for my team, and then nobody comes to actually use them. So we're finding a balance, but yeah.
Great. So the last talk for this session will be the LabID meets Galaxy from Joe.
Thank you, and thanks everyone for sticking around. It's quite hot. Guess everyone is happy if can go. So here I'm today presenting LabID and the integration that we've done with Galaxy. So a quick word about me. So I used to work at EMBL, where I've written basically the first lines of code of LabID, and I've been contributing ever since to this open source project. Sorry, and since leaving EMBL, I've started my freelancing company, and through this, I've been able to work on a cost-funded EMBL project where we wanted to have the enable the continuous provenance from samples to results within LabID. So today I will present LabID and this project, or more how we integrate Galaxy in the workflows in LabID. So what is LabID? LabID is an all-in-one fair open source data management platform for life sciences. It's being actively developed at EMBL Heidelberg, and it's used across the EMBL sites and expanding also to other institutes. So it's really tailored toward life sciences, and it comes in this modular kind of setup where we have lab collection management, where we have consumables, equipment, storage equipment, where of course you can then store your consumables, and we have the biomaterial management system where you can describe your samples, your specimens, so in a broader sense doing your biobanking, and we have the electronic lab notebook where you have your project, your experiment, and your protocols described. And what we focus on today a bit more is the dataset management, so where you describe your assays, your data sets, and your workflows and your studies. So what we mean with this provenance is we want to capture high quality metadata from creation to dissemination. So really going from tracking your specimen, your samples, the assays, the protocols that you use in between, consumables that you've used, going to your primary or raw data sets, capturing that information in your notebooks, and having your derived data sets. So, of course, also tying this together with an electronic lab notebook. So why is this important? I mean, it's quite obvious, but of course you want to track the information in your lab, especially if you have a high turnover. You want to know what was done in my lab, what has someone else done. So you want to have this information ready. You want to be able to share high quality data with your collaborators. And of course, also, if you want to publish your data, you need to have your data already well annotated, and you want to do this as soon as possible and not at the very end. And of course, also in the age of AI, you need to have still high quality data, and especially also your derived data annotated and and well described to be able to have high available models. So how does that look like in LabID? So this is an example of a fly line sample. So these are some embryos. We have our typical information about the name, the unique identifier, which organism is this. Of course, this is also controlled. We have controlled vocabularies for this. In which location is this sample to be found? We have the protocols, as I mentioned. So this is an ordered list of protocols that you have applied to that particular sample. And then we have the annotation. So these can be your experimental variables, but these can also be any other kind of annotation that is not a generic information that you need for every sample in your system. Then with this, we provide this kind of lineage view where in this particular case, we are looking at these embryo samples that came from a fly line cell line. You extracted RNA and you have then your multiple sequencing libraries prepared. So this can be then viewed at a glance quite easily. Then, of course, also if you have described these samples in your ELN, you can do so. You can view that information there. So for raw data, so especially if you have your sample or your, for example, your sequencing experiment, you want to generate raw data, you want to load this data into your LabID system. So for this, we provide this user interface where you basically say which kind of assay is this, and then you provide as much information as possible for your data set in this system. And if you have done that properly, you get again this kind of lineage view for this particular sequencing experiment where you have your data sets on the one side, your raw data sets, the assay, and the samples that you had before. So what about the derived data sets? So we can already, or we could already describe this for quite some time already. So you could describe these data sets I've registered and came from these raw data input sets. However, what we lacked for a long time is actually describing the workflow, how you got to that kind of data set. You could already describe that by some annotations, but it was not really structured. And what we did within this LabID Pro for this OSCAR-funded project was to be able to capture that workflow information. So for the workflows, we modeled those kind of workflow entities. So I'm not going to go too much into detail with this. But basically, you have your workflow run, or in Galaxy, it's called a workflow invocation that is actually describing this particular workflow version was run with this input, with these parameters, and we got this kind of output derived. So what do we support? We support the import, creation, and export of workflow versions. So from Galaxy, we provide, or for Galaxy, we provide a user interface where you can specify directly a workflow URL, or you can search Galaxy, like EU or any other public instance, or your local one. And you can import that information and we get the metadata installed in LabID. Similarly, we import RO-crate formats from Workflow Hub, for example. For this, we also provide a user interface so that you can directly search your Workflow Hub and import basically any RO-crate that they have. As well as if you have your workflows not in one of those systems, but you just have your own Git repository. So this could be your Nextflow or SnakeMake workflow, for example, or any other bash script that you might have in a Git repository. You can import this as well. And you can import basically any tag or commit version that you want to have back into LabID. And similarly, if you have your local files, you can provide an interface to create your workflow or describe your workflow in LabID and upload your files. And then as well, we export those kind of this metadata as an RO-crate. So you can send this directly to Workflow Hub if you want. So you can publish your workflow directly, or you can download this RO-crate for further work or share with collaborators. Then similarly for the workflow runs, we provide a similar interface for Galaxy. You can basically search your Galaxy instance and import your workflow run metadata. And similarly for, you can describe your workflow run just through the interface. So basically the manual approach. Or if you have an RO-crate on your system, so you run your workflow, you export at the RO-crate, you provide a CLI, so the command line interface to import your workflow run from this RO-crate, importing the input data sets and the output data sets and link them together in the system. Or if you have directly your output data, your workflow run output directory, you can launch this command line interface to basically register those data sets in the system. So for Galaxy, we still have, so what we already were able to do for a long time is we can send our data sets that we have in LabID, so be it your raw data sets to a Galaxy instance, and mostly this was aimed at on-premise installation, so for your local Galaxy instance where we were not actually copying any data, we were just linking the data into your data library, and then you could run your workflow and that data was there in your data library and within Galaxy. So what we've been working on, and that's not yet fully there, so there's a merge request open to get this well organized, but you get your workflow run basically also then imported in LabID. We import the data sets, link them together, and then you can start the cycle again by sending your data sets to Galaxy. Why this is not yet there yet? I mean, there's a large merge request open, and we want to leverage basically the object storage where you can have your shared S3 system. You can send the data sets there, LabID to there, have either deferred data sets in Galaxy or properly download them, or we might go to the route of uploading the data sets directly to Galaxy. That's all already there, but we need to optimize the user flow and get that merge request basically in the system. So this is another example of basically importing such an arrow crate. This is an image conversion step. So this is from TIFF to OMISAR. So that's quite simple workflow in this case, where you can then indeed import through the command line interface this arrow crate and get this kind of lineage for your image data sets as well. So you can see indeed the derived data set, the data set before, and the original specimen. So with this, I'm coming to the final slides already. I think I went quite fast. So if I haven't mentioned it, LabID is open source, so you can find more about it on this website, labintegrateddata.org. You can talk to us, of course. We have a poster tomorrow. We provide documentation, training materials, and videos on this website. There will be an in-person training in Heidelberg in the end of September. So that's run at ML Heidelberg. So please scan this barcode if you want to participate, or join our Slack also by scanning this link, or find it on the website. There you find all the other links. So quick trigger warning: if you don't like commercial solutions or you're allergic to it, please look away now. I just want to mention I will provide soon a hosted solution for LabID called LabRISE Core at labrisesolutions.com. You can sign up for the mailing list if you want to learn more. Please come talk to me. And this will be a subscription-based cloud solution for anyone wanting to have a LabID installation. So with this, I want to thank the team. So Charles is also here in the audience. He will also be around if you want to talk to him about it. As I mentioned, we have a poster. This is the rest of the team, with Laurent being more active on this OSCAR project. He's been dealing with these arrow crate formats quite a lot. He's helped me also with integrating this in LabID. And yes, thank you very much.
So to just be clear, so the lab ID itself is open source, but if you want to make it easier for you to run, then that is commercial, the hosted solution.
Right.
So we can still do all of this with the open source.
You can fully get your LabID installation on your local machine. I can also help you install it if you want. But yes, so anyone can take it. It's an MIT license on the LabID software, and the cloud solution is just a bit on top.